Entonces, este primero es sobre una aplicación de Ignition asociada a pues unos trineos. Obviamente, pues nosotros no tenemos trineos ni tenemos nieve en estos lados del mundo, pero igual es chévere de alguna manera considerar.
Of course, an ongoing digitization project that we're going through. Aaron's Co. is a maker of snowblowers, lawnmowers, push behind, zero turn for consumer and commercial markets. So we came together with them and decided to implement a solution. So the process for the operators at Aaron's was to track all the produced parts and scrap by hand on pen and paper. And once that data was tracked, then it was collected into a digital format via manual data entry. And then the final step of that process was to take that data and leverage the highly complex tables to service the efficiency of the work center. And the data was aggregated to determine the overall plant efficiency. Manual data collection from the operators, while it had been effective in the past, was starting to become outdated and needed to be addressed. And so some of the errors from the manual entry easily multiplied across the various translations. Operators might make an error when transcribing a part count. Analysis might input the wrong value when transcribing a digital format. And there was also room for additional error when driving the data calculations through unlocked and open forms. This stacking of potential errors left Aaron's exposed to risk that they deemed no longer acceptable. So the solution, to solve these problems, we made several improvements. First, we changed the process for the operators. Aaron's was already in the process of installing Horner XL7 PLCs to 116 different machines, welders, laser cutters, brake presses, paint booths, etc., with the purpose of collecting as much data as efficiently as possible. The new process was for operators to scan their physical work orders for each production run from MOs, their manufacturing orders, that came directly from the ERP. All that information gathering was triggered from one barcode scan, and then the PLC and Ignition handled the rest from there. So Aaron's worked with Corso Systems to handle taking the data and creating a real-time OEE engine for analysis from the plant level all the way down to the individual work center. Within the scope of work, there were several major areas of focus: connectivity, PLC interaction, ERP interaction, data processing, and visualization. With the connectivity portion, Corso was tasked with assigning the Aaron's crew, or assisting the Aaron's crew on troubleshooting connectivity from the hardware side, and was able to confirm once machines were online via Ignition. The PLC interaction was much more involved, as the Corso team and the Aaron's team needed to work side by side from opposite ends of the line of communication to make sure the two programs were speaking different languages while communicating through the proper translation. Corso needed to make sure that all the parts counters, operator scans, scrap counters, manual adjustments, and timestamps coming from the PLC were high quality data points, and again used Ignition to validate that process. The ERP interaction streamlined the separate data sources. The manufacturing order is scanned, and on the fly, that number is then sent back to the ERP via the web dev module to gather all the information regarding that part or parts, depending on the process. All information regarding the engineering studies performed is stored in the ERP and it keeps everything centralized. With having one data source, Corso was able to eliminate potential noise when translating from one system to the other. The ERP connection also served as an endpoint to handle associating operators' RFID badges with their employee identification numbers through an AD integration. Upon process completion, the part counts were passed up to the ERP to update inventory, aiding the scheduling and planning side of the operation. Once all that information coming in had the proper designations coming up to the PLC and going out to the ERP, the Corso team was able to incorporate everything into the SIPSoft production model to perform analysis and calculate real-time OEE for general and granular aspects of the plant. The navigation system. We saw this as probably the most central part of the integration. What we did was take the information pulled from all the machines, operators, and ERP, and we needed a way to visualize everything in a clear, understandable format that high-level executives and on-the-floor operators all understood at quick glances. Corsa was able to create a navigation system that allowed the user to glide through the different scopes of the plant and also adjust the metrics that they were viewing: performance, availability, downtime, quality, OEE. Either can be adjusted on the fly, scope or analysis metric, in order to allow flexibility when comparing work centers to each other and looking at different metrics for each work center. Mix in the navigational strategy with the custom screens and a dashboard widget created custom by users and saved to their profile, and Corsa was able to create an efficient, high-powered visualization scheme for the errands team. So the project scope. There were over 3,600 device tags and over 8,500 live analysis tags. We limited it to 9 perspective pages for to keep it kind of narrow as possible, so that we didn't have people having to jump too far around. We went with unlimited clients so that anybody, anywhere could access this via desktop or mobile. And then we have 360 total alarms, 3 per device. The devices were the previously mentioned Horner XL7 PLCs, and then 4 Bystronic brake presses, standard architecture. And then the databases we used were the 3 SQL servers, a general application configuration database, historical, and Sepasoft MES. And then there were over 7.5 million rows and 1,600 tags logged historically. Getting into the screens and the navigation. So on the left-hand side, you'll see our main navigation driver. We've got our OEE, custom dashboards, and our reports that we used for validating communication with the ERP with the MO scans. And then we get down to scope. This is built out so that we can have additional plants, as they have plants all over the country and world. So right now we have plant 1, and then we have the individual areas: cutting, forming, welding, machining, paint, and assembly. And then from there, you can dive into the individual lines, 530, 540, and then the individual work centers themselves. You can also adjust the scope based on time on the left. And then if you want to adjust based on OEE, availability, performance, or quality, you can mix and match, kind of choose your own adventure. So if I were to click on 540.0532, it would bring me to this next screen here, and it would further dial into it here, giving us kind of a breakdown of our quality, performance, and then availability, as well as information on each work order and how that was performed. This is an example.
Profe, se le fue el audio al video.
Listo, ya miro, ya estoy mirando. Bueno.
Sí, señor.
No, el original está sin audio ahí, creo. Listo, les decía. esa es una opción de Ignition, interesante, chévere de revisar. Esta otra es una presentación de AVEVA. AVEVA es un monstruo gigante. Ha comprado Wonderware y eso era la solución de Schneider. Entonces, o Schneider compró AVEVA, no estoy muy seguro cómo es el orden ahí de los quién compró a quién, pero definitivamente AVEVA es un actor muy interesante de escuchar. Vamos a escuchar a ver este otro video.
Profe, qué pena, no se escucha.
Ya miro.
Solutions, whether it's PCs, industrial panel PCs, servers, embedded mobile devices, IoT devices. And one of the big features of the product is the ability to develop your project once and deploy and run it anywhere. We can run on different operating systems and deploy that in different ways.
Listo, ahora sí está funcionando.
A little bit as we get going through here. Some of the main benefits, if you take a look down here, the left side, we have portability, mobility, and interoperability. And these mean different things to different people, but I'm going to explain a lot of this during this presentation. But I'm going to come at it, instead of just dumping on you some features, I'm going to show you why this is a benefit and how this can benefit you. And again, the mobility part of this, being able to view and interact with the screens on remote devices, whether it's tablets or phones, or as well as desktops, either at your location or geographically distributed, independent of where you're at. The interoperability part of this is being able to communicate to many different devices, many different included drivers and protocols. But in addition to the drivers that we have built in, such as not only PLCs, but such as robots, temperature controllers, motion, vision, etc. The ability to communicate and interact with databases, cloud-based infrastructure via MQTT or even OPC. So many different ways to communicate. Now, the portability part of this, and when we take a look at this, there's a development environment, or an integrated development environment, often called an IDE. And that's what we call a Viva Edge Studio. Now, Studio, again, is the development part of this, and you can deploy this to really 4 different runtimes. One that we call a Viva Edge SCADA. Now, that's on Windows desktop or server operating systems. Edge embedded HMI for Windows IoT, enterprise, either LTSB or and then we can also deploy it on what's formerly known as Windows CE, or the runtime license that we call Compact HMI, and then even running on Linux, what we call IoT View. And that flexibility really gives you the capability to pick and choose and scale. For example, if you happen to be a machine builder or system integrator, you can offer your customers kind of a standard level product, a high-end product, and maybe a low-end product based on cost, based on size or resolution of the panel PC that you want to use. And the other benefit is the ability to develop once and deploy anywhere. So that really gives you the ability to develop this project once, and with little or no changes, often no changes, be able to deploy on different hardware, on different operating systems, different resolution and different size screens. So that's a huge benefit because really, when you think about it, your personal product is your time, and that we know is very valuable these days. So this paints a bigger picture. If you take a look here, where does Aviva Edge fit into the bigger picture? Down here at the asset location, now we've shown kind of a manufacturing environment here, but it does not have to be a manufacturing environment. It can be process, it can be infrastructure, it could be utilities, water, wastewater, wind turbines, wind farm, solar, et cetera, and being able to then get that information from the edge type devices, the edge of your network where the things are happening, so to speak, and then get that up into other Aviva products, whether it's InTouch, system platform, or into our cloud-based products, for example, Aviva Insight, and being able to do some analytics and understand what's going on in your process and being able to improve, feed that back, get actionable insights, improve that stuff that you're doing every day. So the first use case, first here of 7 that I have to show you today, many different PLCs and devices. So something that we often hear is we have many different PLC brands and different devices with different protocols. I just wish we had one HMI platform that could connect to everything. And this is something that we hear, especially going up against our competition, where the number of drivers that they have is often either small or non-existent, and you have to add external technologies or external modules, things like OPC, or add on things to get to additional protocols. One of the nice things about Aviva Edge is that we have over 100 protocols built in for different PLCs. And again, not only PLCs, but things like robots, temperatures, motion control, vision. And in addition to the drivers that we have built in, included, we can also be an OPC, UA, or DA server, or a client. So if we're a server, we can get to, if we're a client, we can get to third-party servers and connect to other devices. Maybe we don't have a driver for a particular device, or maybe a particular feature that you need in a driver is there, or manufacturer supplied it. So we can get to that again with either OPC, DA, or UA. If we are an OPC server, then third-party clients can come access our tag information. So if you look at the center of this diagram, it's really Aviva Edge tags here, and not only via drivers and OPC, but interaction with web services and databases, and we can even have toolkits so that you have the need or necessity, you can develop your own toolkit or your own interaction with our tags, and or develop your own drivers as well. But supporting REST APIs, supporting different drivers, OPC built in, and again, OPC is not necessary. We have over 100 drivers built in. You can probably get to the PLC or the device or the thing that you need to communicate with. So making that kind of easy as you go. So let me hop over to the development environment here real quick and show you. Here's a project that I had just started up. And what I'm going to do is right click and add, remove drivers. And here you can see the different list of drivers that we have. You can add those to the to your project. So let me just add, for example, Modbus TCP, pretty widely used. Could be Ethernet IP, et cetera, et cetera. Let me add that to the project. Now, another big advantage of this product is that the drivers are mostly independent of the version. What do I mean by that? That you can use older versions of drivers with newer versions of product and vice versa. Why is that a benefit? You may have qualified or validated a particular driver and want to keep using that even though you change the version of the product. that might be something advantageous of you, or different variations of that. So that is a unique thing that we have independent drivers. So adding the drivers in here, you also get the ability to have read and write statuses, so that you can understand if your information is being read properly. You can also choose, for example, if you've got bad quality, if something happens to the PLC, you can show question marks in the place if you don't want to show invalid data, for example. And then you also have the ability to enable or disable the driver worksheets. And why that's an advantage is because you can add, we have no license limit on the number of drivers that you can put in your project, and you can turn them on or off as necessary. And this helps facilitate the idea of having one project that serves many different applications. So you can have maybe an Allen Bradley PLC or Modicon PLC, a Schneider, et cetera. And depending on the project, enable or disable the driver sheets as needed for the particular project, so you don't have to redevelop that interface as that goes. So again, not only the flexibility for the status, but also the ability to have different PLCs at different IP addresses, different locations, and the flexibility to change between those as you go. So let's go back here to the presentation. The next use case is we have too many HMI products in general. So some of the things we've heard is over the years, for example, we've added machines and skids with different types of HMIs. We've never really paid attention to the brands of HMIs that have come in, but this makes it difficult to maintain and train on the different technologies, not only for the operators, but for the maintenance staff. And in general, we need a way to reduce the time to converge into a single HMI platform. So we hear this often, especially from integrators and people who may have had just the need to combine their different HMIs. Maybe they've had way too many, and now it makes sense to bring that into a single HMI platform. But the time to do it is maybe prohibitive. So what we've done, we have 3 different import tools. So starting here at the bottom, we have an import tool for Eaton PanelMate. We have one for Rockwell's Panel Builder 32, and then also for Rockwell FactoryTalk, either ME or SE for FactoryTalk View, again for Machine Edition or the SE Edition. And what that allows you to do is import a project developed by these other products and get that into Aviva Edge. Let me move my little window out of here. And it drastically reduces the time and the engineering costs for that. But then what you end up with is, at your choice, your discretion, you can have the project look like these different products, or you can enhance that and take advantage of the tools, the animations, the visibility of the different objects within Aviva Edge, and then take that above and beyond. So for example, if you brought in a FactoryTalk View application, it would look and feel like that, but then over time you can enhance that and not put too much stress on the operations staff or the maintenance staff, but then improve and take advantage of the features within Aviva Edge. During the import, end up with a project that is truly an Aviva Edge project, and you have native objects from Aviva Edge and the ability to use those and enhance those way above and beyond the functionality of those other products. The next use case is something that we hear a lot of, is we need to understand what's going on, the performance and the key performance indicators. And there's many different variations of this theme or idea. And it really comes down to, we realize we don't completely understand our performance and the downtime causes, the key performance indicators, however you may call this, whether it's OEE for overall equipment effectiveness or just data logging or trending in general. What I've seen over the years is going into facilities and a supervisor might ask one of the maintenance staff, hey, what is the worst problem, or what's the most downtime causing thing that we have on this machine? And he'll think about it for a second, and he'll say, well, last week we had blah, blah, blah thing. And it turns out humans are just notoriously bad at remembering all those details. So by being able to log trend to databases, local files, cloud-based, and being able to analyze that really completely gives you the ability to measure it and make data-driven decisions. Now, within Aviva Edge, we've got a lot of different solutions here, and I apologize for a lot of the different text here. I'm going to simplify this and just do a couple of different things. We have the ability to log not only to a local file in the hard drive, but also to databases, SQL relational databases, and it can be any SQL relational database. It could be a Microsoft SQL Server or Oracle, MySQL, Postgres, the list goes on and on. Also, we have the ability to use the Aviva Historian either on premises or what's called the Aviva Insight in the cloud, and push data to that. And that is something very easy to do. Let me flip back over to the development environment here. And as you put tags and things that you're monitoring in the project, one of the really easy things to do is flip over to tasks and set up a trend worksheet or a trend logger worksheet. And if I just right click on that and insert, and I put my list of tags here, by the way, this list will grow to thousands of line items long if you're not limited to these 4 or 5. You can put a tag in here. It does not have to be time-based. It could be, in this case, it's the seconds clock of the computer, but it could be end of cycle of the machine, end of process, end of batch. You get to trigger that as necessary. Or you can save whenever there's a tag change. Now this lets you very easily, if there's any problems, any tags that change, being able to get that log, that entire list logged to a database. Now moving on, that will by default log to a proprietary database on the proprietary text file on the hard drive, on the local hard drive. And by the way, you do have the ability to set up what's called history, lifetime, and days. So if you only want to keep 30, 60, 90 days around that, just to ensure that you won't fill up your hard drive, you can do that as well. Now, moving on beyond the text file on the hard drive, you can move to a SQL database and be able to get that into any SQL relational database. Very, very easy. And we've got lots of demos online if you need a demo of how to do that and how easy that is. I usually challenge customers to time me, and I can do it typically under 5 minutes, but for sure under 10. But what's really nice is we don't require an external SQL database. You can, again, use that local text file on the hard drive. The third type of data here is going to the historian. Now, if that's the Aviva Historian on premises, we have a way to configure that. We also have a way to get to Aviva Insight in the cloud, and really being able to do that very, very easily. So there's your really 3, almost 4 different types of data collection and different ways to do that. Now, all of these basically say what I just mentioned, third-party support, but not only data logging, but for alarms and events as well, and really be able to trace and track what's going on in your production environment, your application. And again, being able to take that data from the edge type devices, whether that's valves, pumps, motor controls, whole machines, whatever you consider the edge, so to speak, being able to get that data, not only just kind of a pass through, but also more of a data acquisition, data manipulation, and aggregate that data, filter, contextualize that information before you send it to where you need to analyze that, whether it's a cloud-based analytics or on-premises historian. And often when I show this slide, what I like to do is draw a giant circular arrow here, because really you need to take that information that you've gained from that analytics and feed it back into your system and help improve it. And that's kind of what it's all about, not just analyzing the data for the sake of analyzing the data. Now, I mentioned when I showed the historian selection in the database configuration, and we have a tool called Aviva Insight. I really invite you to check that out because with very little or even no configuration, that tool can automatically analyze the data, the tags that you sent to it, and it will compare tags against all other tags and learn what's going on and evaluate and show you when there's any things that are outside of normal ranges, and you don't even have to configure that. Really slick kind of tool. So again, that's Aviva Insight, and we can push data to that as well. So the next use case that we want to talk about is I'm tired of extra modules. We've had several projects where we just didn't know, and I'm taking on the voice of the customer here, if that wasn't obvious. We've had several projects that we just didn't know that we needed extra modules. We missed it. We didn't order the right things for things like alarming or recipes or drivers or database connectivity or reporting. We've had to go back to management for more funding, more money. And then we had to go to purchasing to place another order and then wait for things to be delivered or licenses to get upgraded. So really what's nice about the Aviva Edge tool set is it's comprehensive, meaning it's everything included that you need to create an HMI or SCADA project, again, for everything that you need. So I've shown here kind of the development ribbon interface and some of the tools that we have, just as more of a reminder or a checklist for me, because you get all of the drawing tools, you get all the animations, the ability to tie in external objects, the ability to do remote management, remote troubleshooting, to manage your tags database, all your graphics, all your background things that happen like alarming, trending, recipes, reports, scripting. There's 2 or 3 different scripting languages in the product. The ability to interface with your drivers, multiple different drivers simultaneously, as well as OPC. I didn't mention this earlier, but in addition to the other drivers that we have, I think I did maybe mention MQTT as well. But the ability to create your own graphics, industrial graphics, everything that you need to manage, facilitate, create, and deploy a project is all included. Now, the next thing that I like to show here is the different vertical markets that we're involved in. And we're really in every different market, as you can imagine. I typically point out this rightmost slice here because it really points to that we are in every different type of industry that you can imagine. And why do I point that out? Well, this is how we got to the place where we are with so many different features in the product. For example, pharmaceutical customers asked us to support a US FDA standard called 21 CFR Part 11. Basically, that's the traceability, trackability, and security to maintain and watch over a project. For example, who changed what ingredient from what to what, and when did they change that? Who was logged in? So as we got the different pharmaceutical type customers, we realized that would benefit other industries. So we looked to see how could we add that feature into the product and then make it available to other types of applications, other types of industries. And so that's how we've really added the features over time and added that capability and functionality to really have all the tools that you need to create an HMI and or SCADA type project. The next use case that we hear a lot about is we're never in the right place at the right time. So for various reasons, we have less operations staff, maintenance staff, and they never seem to be in the right place at the right time, or they're geographically dispersed. So one of the things that I hear is, for example, 15, 20 years ago, it wasn't uncommon that if you had 10 different machines, you had 10 different operators, one-for-one relationship. And now either it's for the times we're experiencing in 2020 or for whatever reason, maybe people are just wanting to be more efficient. They have less operators, less maintenance staff, and they're never in the right place at the right time, or they're physically out in a field, or maybe you have a water or a wastewater application and you're really in different places at different times. So what are the different features within Viva Edge that can help you understand and deal with that. So we have several different thin clients with the product. We have a mobile access thin client, and that's HTML5 interface. You just open up a browser, point it back to the real running application, and view and interact with those screens, of course, with security in mind as well. We also have a different type called Secure Viewer Thin Client, and that one also gives you the ability to view and interact with different devices remotely. So here's some of the benefits: secure, portable, flexible, customizable, scalable. I'm going to talk a little bit more about those, but you can use these on different devices. Now, Secure Viewer Thin Client needs to run on a Windows based device, but the mobile access thin client does not. It's an HTML5 browser based. You don't have to have any plugins. You basically open up a browser, whether it's a Windows device, an Android, an Apple device, could be a desktop, could be a mobile tablet, phone, etc. Point that back to your real running application, and again, view and interact with that. So if your maintenance staff, let's say, happens to be at another machine and something happens across the way, well, they can determine, hey, is that higher priority? Do I need to leave what I'm doing now and go take care of that? In the case of, let's say, for example, utilities or an infrastructure type thing, maybe the person is at home or it's the weekend and they need to be able to get that information to determine, hey, do I need to really go in and take care of this, or can I bypass that valve until I can get in tomorrow morning or on Monday kind of thing. So lots of different capabilities and flexibilities with that. So if I open up, let's say, the development environment here, and let me load up what's called our PC demo. Now, this is the demo that's included with the product, and here you can see that we have really all of the features and capabilities, whether it's recipes, reports, trends, all built into this product. But what I'm going to do is I'm going to launch the mobile access client here. I'm just going to click on that. It's going to open up my mobile access client, and again, this could be on really any type of device. I'm gonna revise this to be more like phone might be, and just show you that you can get at different screens and interact with those remotely. So also, just if you want to see this demo live, I encourage you to take your phone, your tablet, your desktop computer, and just do a Google search for Aviva Edge, hit the Aviva Edge page, and there's a live demo button that you can click on there and get this demo across the web and show you how easy it is to interact and just spin up and get to that remotely. So that's kind of a nice demo there. The next thing is a use case for, we need more visibility and just general understanding of what's going on in our facility. So production and operations staff need at a glance visibility to current status. Maybe they're not near their office, not near a computer. They're out tending to the needs of the facility, whether that's a manufacturing facility, some big process happening. And another thing that's also advantageous is by making production status available to everyone, we want to encourage everyone to be just keep production moving. It's an incentive that it's kind of like a scoreboard. You see that, and you just want that to be available. So what we're talking about here is something like Andon. If you're not familiar with Andon or production monitoring, it's called different things. Could be digital signage, could be factory information systems, could be big screen TVs or big boards up in the rafters or hanging on the wall. It allows you to quickly visualize the status and understand what's going on. And I always like to say that machines are like printing presses for money. If you realize this, that you know, you're making a profit on every product that's coming out of the machine, or if you're running a process, continuous process, you know, whatever you're making or manufacturing, there's a profit associated with that. And if it's not running, it's not making money. And if it's stopped, you need to get that running quickly. You need to be able to understand what's going on from a distance, and I'll talk about that more in just a couple of slides here. And you can also encourage safety more. Maybe there's employees that don't have email. How do you information? You don't want to hand out pamphlets and things like that. So how do you keep information like this in front of employees? So one way would be to have the thin clients. Now, this could be either the secure viewer thin clients that I mentioned before, or mobile access thin clients, and have big screen TVs or big screen monitors hanging up with either local computers, or these could be browser based as well. I know some of the big screen TVs that I've tested have built-in browsers that happen to work. You would need an external computer for those. And some of the benefits of this is being able to have hundreds of these. Notice here I have this little dashed line. You could have production information, OEE for overall equipment effectiveness, just general what's going on. You could have one of these in the cafeteria, let's say, or break room, and provide information about what's going on, the weather, the stock price, just information, so that, again, keeping employees informed. This could also be a facilities type thing where you're monitoring energy usage or building automation type things. And you can have this rotating between different screens. And what's nice is these are easy to replace if necessary. Basically, you put in a new device and configure it where it needs to go to, and it's pretty much up and running at that point. Now, taking this idea and continuing on with it, expanding upon that a little bit, is this type of application where you have a video wall and you have maybe a multiple set of big screen TVs. In this case, I've got 4 TVs in a 2x2 matrix, and these could be 4K screens. These could be 1080p type screens, and it doesn't have to be in a 2x2 matrix. You can get Aviva Edge will support up to 10,000 by 10,000 pixels, so you can, visualize this from very far away. We've done studies with some college students where we've actually determined how large do the characters have to be so that they can see them from 50 meters, 100 meters, 150 meters away, and how large do the characters have to be when they're at those different distances, and they can see the individual characters from those distances. So, and again, giving you the ease of being able to create screens that span multiple monitors very, very easily, again, from one runtime. And as I mentioned back here on the previous slide, that you can have hundreds of these clients really off of one individual server. So it's not a video cable. This is a network, and each of these could be different screens. They could be the same screen, could be dependent on where that is located, whether it's in a cell, manufacturing cell, a zone, a region, a cafeteria, etc. So lots of different capabilities when it comes to that. Now, another use case that we have here is the idea of reducing downtime and mean time to repair. So, this is the really critical thing when it comes to HMIs and your SCADA system. It used to be a long time ago that an HMI was just a way to replace push buttons and pilot lights and meters. Now it's so much more. We hear from our customers things like we need a new and different ways to reduce downtime and get things running again quickly. So there are lots of tools in Aviva Edge to be able to do that. In addition to the standard troubleshooting tools that we have, being able to view communication statuses, troubleshoot communication statuses, you can also provide operators and maintenance staff things like opening up PDFs and showing a step-by-step, how do you fix this trouble, this thing that we've run into before, or how do I learn from those things? You could be web pages, could be playing videos, email, text messages to get to people, audio alerts. I've seen some machines in some factories play musical tones over and over again until the maintenance staff comes and fix the problems, kind of an annoyance kind of thing. And this is an application to kind of give you an example of how you might show videos or web pages or PDF type help. So if I go back to, let's stop this PC demo here and go back to my runtime my development environment. and switch this project over to an example that I have called Alarm Machine Circle. And if I run this, what you'll see here is I can simulate some alarms. So let's go into the alarm field here, and I'm just going to push these little buttons and simulate some alarms. So here I have a toggle error, a die error, a hopper error, and a base error. And I just made something simple just to make it understandable. But what I'm actually doing behind the scenes, you don't have to display these, but I'm displaying an X. You don't have to display these, but what I've assigned for each alarm is an X and a Y position, and I'll show you what that's important for here in a minute. And then I've also assigned an alarm file name. This could be a PDF, an HTML file, a movie in this case. So what I'm going to do here is go to the hopper, and when I select that, behind the scenes, I get this information here. In this case, it's the hopper PDF. And when I go to the machine screen, it's going to show me, it's going to move that circle to that X and Y coordinate and show me where it thinks that alarm issue is. And if that's still not enough, it's past that hopper.pdf file name. You can see there with the tooltips, it highlights that. And I can open that up, and then I can get my steps. For example, what do I have to do to fix this? Check, is the hopper blocked? Maybe there's a sight glass that you can see into it to check the moisture level, the air pressure, et cetera, to be able to troubleshoot that. Now, if I go back and maybe I take a look at this one, maybe it's a toggle error. Now, in this case, the circle has moved, and I can click on that if I need more information. And it's actually going to display, now this is bottling, it's not really a plastic injection molding, but there's a video that I happen to have handy. And so I just wanted you to see that many different things that you can get at to help you troubleshoot, trial, understand what's going on in the machine. So those are the different kind of use cases that I wanted to show you, some big picture things of how you might have some pain points in your organization and how Aviva Edge can solve those. So understand, and some key takeaways, that this product is very full featured. It has really everything that you need, from alarms, graphics, recipes, reports, all the drivers built in, all the different tools that you need to create a project that helps keep your process or your machines running. It's flexible and open. So not only do we have the tools that you need, but we can tie into other third-party tools. We recognize that you have the need to be able to do that, whether it's OPC, ActiveX and .NET, web services, the list goes on. And it's sustainable and affordable. We continue to evolve this product and make sure that no matter where your budget comes from, whether it's CapEx or OpEx, you can facilitate a project and get that going for you and those types of needs. So with that, I would like to thank you for your time, your watching of this, and hopefully you learned something. Please contact your local Aviva distributor and get what you need from them.
Bien, chicos, regalen un segundo. Recuerden que la tarde de hoy es una tarde de preguntas, es una tarde de cuestionamiento, es una tarde de resolver inquietudes de todo este taller. Entonces, en este momento, ¿me pueden escuchar? Claudia.
Sí, señor, sí lo estamos
Sí,
escuchando.
perfecto. Entonces, en este momento hay una pregunta y nos dicen, oiga, con AVEVA se pueden todas las escalas de la pirámide de automatización, ¿verdad? Sí, definitivamente es un producto o es una, yo les decía, es algo ya monstruoso de lo grande que es, y definitivamente usted con ella sola puede tener todos los niveles de automatización. Pero Siemens también le va a decir, yo también puedo tener todos los niveles de automatización con mi solución. Rockwell también tengo todas las soluciones de automatización de todos los elementos de la pirámide de automatización con mi solución. Yaskawa también les va a decir lo mismo. Entonces, digamos que eso es más una aproximación comercial. O sea, yo quería que vieran como otros discursos, digamos, distintos al que Yo vendría a acomodarles cuál es el mejor de todos. No, no hay una respuesta. O sea, eso depende mucho del proyecto, del cliente. O sea, no es una cosa que el mejor es Siemens o el mejor es Rodwell, el mejor es AVEVA. No, digamos exacto, todos son buenos, todos tienen sus cosas positivas, sus cosas negativas. Casarse con una sola marca, pues puede tener sus ventajas, mientras que están en luna de miel. En el momento en que cambian algo desde la casa matriz y no se acomoda al cliente, pues ya uno comienza como a perder el encanto. Y si esos cambios, pues definitivamente le cuestan a usted más dinero después de haber hecho el pago inicial, pues ya, digamos que ya no es el mejor. Sí, entonces, digamos que todos tienen su cosa buena. ¿Qué es lo interesante en ese momento? Y digamos que, pues igual todos lo tienen, ¿no? Que sea abierto. O sea, que usted no tenga, y sobre todo en las latitudes como las nuestras, que usted no tenga que comprar el cable verde y el cable azul para conectar los otros equipos de red y los equipos de campo. Y solo así le funciona. ¿Sí? Y si le llega una máquina de otro fabricante de automatización, y usted tiene que darse la pela pues para que eso le hable, digamos que ahí se vuelve harto. Entonces, de alguna manera, eso es lo que eh, usted tiene que asegurarse cuando está en el tomador de decisiones y decir, venga, yo necesito aquí transversalidad. Si hoy me resulta atractivo, por ejemplo, comprar X maquinaria en México para que se integre a mi proceso y yo estoy casado con el fabricante que sea, pues yo aspiro que ese equipo que yo traigo de México, que me resulta, esa planta, esa línea de producción, lo que sea, me resulta en ese momento muy rentable o muy estratégico comprarlo, pues que se acomode, ¿cierto? Pero si mañana lo quiero traer de China, pues tengo que asegurarme que lo que me vendan los chinos se acomode a lo que yo tengo acá y digamos que eso se logra mientras que haya apertura, mientras que haya transversalidad. Y eso es lo que el OPC busca, que usted no se case con una sola marca y que quede amarrado a eso. Y entonces fíjense que aquí está el OPC UA, otra vez ahí arrancó la presentación con él. Entonces, digamos que esas son las cosas chéveres de revisar y que vale la pena pues que tengan para decir uno, ¿es el mejor? No, pues es muy bueno. Sí, es muy amplio. Y digamos que son cosas de revisar o sea, no solo tenemos Rodwell, no solo tenemos Siemens, tenemos, obviamente aquí estamos viendo a Beba. Por ejemplo, este otro que vamos a ver,
Thanks, and have a great day.
este otro que vamos a ver, se llama Genesis 64. ¿Por qué lo traigo? De acuerdo con la visión de negocio que yo tenía antes de la pandemia, que estaba en una posición, digamos, distinta a la que estoy ahorita dentro del negocio de la automatización, ahí me di cuenta que financieramente Iconics, que es un producto que también pueden llamarlo, también se llama Genesis 74, pues era el producto más económico para entrar a un mercado. O sea, si yo necesito una solución de SCADA, de HMI, de automatización, pues yo puedo comprársela a Siemens, se la puedo comprar a Rodwell, se la puedo comprar a Ignition, se la puedo comprar a Beba, pero lo más barato en ese momento, en 2019, el precio de entrada era este. ¿Sí? No sé si siga siendo igual, ahorita no estoy pendiente de precios, estoy en un sabático largo, entonces no lo tengo tan claro en este momento. En ese momento sí, ¿sí? Ahora, que al final fuese la solución más económica, no. ¿Sí? ¿Por qué? Porque esto, a medida que usted le va poniendo pedacitos, 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 va creciendo. Pero si usted, digamos, tiene por ahí un negocio y está arrancando y el alcance de su planta o de lo que sea no es muy grande, considere esto. Aquí en Colombia hay distribuidores, no sé quiénes son, yo no los tengo en el radar. He tomado varios cursos con ellos. Digamos que es un producto eh, chévere, sí. Particularmente a mí me gusta más Ignition. Me gusta más porque es que yo les puedo decir, venga, descárguenlo y pruébenlo. Y es lo que vamos a hacer ahorita en el laboratorio. En cambio, con Iconics no. con Iconics me toca hablar allá, venga, hágame el favor, présteme una licencia, es que tengo unos clientes. Si tengo unos estudiantes, nunca la he hecho. No sé si se han abiertos a esa posibilidad. Entonces, eso digamos, me hace la vida difícil en esta faceta de mi trabajo, pues que es ser consultor en temas de educación y cosas de ese estilo. Entonces, por eso yo traigo la herramienta de Rockwell, porque yo la descargo y se las puedo mostrar a ustedes. Y ustedes también pueden descargarla y pueden aprender. Descargo la herramienta de Ignition y la podemos usar. Con Aveva no he hecho el intento después que se volvió Aveva, no sé. Y sé con Iconics no. Pero Iconics tiene esa gran ventaja. Y es que el precio de entrada es el más interesante. Son $1,200, $1,300 la opción más sencilla para hacer una escala. O sea, es 4 o 6 millones de pesos. O sea, es pagable. ¿Sí? Cuando uno venía acostumbrado a los $500,000. Entonces, obviamente, el $500,000 fue una planta grande, no era para una cosa pequeña. O sea, tampoco es que o sea, bajó el precio así de una a otra. O sea, pero digamos que ya comienza a ser una opción interesante de pago. Entonces, eso es lo que me gusta de esta. Vamos a invertirle otro ratico acá. Entonces, vamos a revisar esto.
Welcome to
Y
the
al final del video, pues si tenemos preguntas sobre Iconics, entonces vamos a hablarlas. Luego de esta parte, vamos a invertir un rato en volver a hacer lo que hicimos esta semana, o sea, revisar la presentación y revisar el video del señor de Perú y hacer un HMI aquí rápido, dejarles ese material ahí en la presentación para que luego ingresen al laboratorio y pues en las siguientes 2 horas continúen pues en esta parte de la actividad. Entonces regálenme un segundo, yo aquí cuadro mis cosas.
Sí, señor.
Genesis 64 video guide. This video discusses the many features that are available in Genesis 64.
¿Tienen audio ahí, cierto?
Sí, señor.
Perfecto.
It provides an overview of how to get started with the Genesis 64 product and an introduction to some of the powerful components of GraphWorks 64 and the Workbench.
Genesis 64 is a suite of modules used for control and visualization of your operations. The main graphical interface is called GraphWorks 64. That's the application which allows you to design your operator screens. So you can see your process points as well as alarms along with trends all in one display. Let us create a simple example here. We will create a tank out of several rectangles. I have a first rectangle here. I will duplicate this rectangle. I'll squeeze it a bit so as we get the inner space of the tank. I'll position it a bit. I will round the corners of the shape so it's more like a window into the tank. I'll duplicate this object again because the second one will be my fill. Let's make it blue. All right. On the left side of my screen, you can see an explorer of my object. I will have 3 rectangles. It's quite useful to call them by names. So this will be fill. This will be the inner space of the tank, and this will be the outer space. Good. Now I want to see the process point here on top of the tank. So I'll go for the dynamic tab and I will add the process point. My data browser opens up. I will specify my server, and I will go for the selected OPC server. From the other space of the OPC server, I will go for the process point that I want to show in the display. Make it a bit bigger. Okay. If I go to runtime, I can see the tank with the process point on top of it. I also want the fill to move according to its value. So I will select the fill and I will add a size dynamic to it. As a data source, I will select the same process point. Now it's a good time to point out that on the right side there is Property Explorer. You can see all the properties of the object selected here, and also the dynamic values, dynamic properties that are specified. So here I specified the dynamic size. I will specify the low limit and high limit of the value, and I will also change the clip property. If I go to runtime, I can see the liquid level in a graphical form as well as in digital. Now I will add some more controls. Let's say I will add the alarm voice viewer to see all my alarms. I'll double click it. I will select the grid. Now I have one tab here which will show me the real-time alarms. I can create a new subscription to my server. Alarms. Real-time subscription for this time. Okay. It's connected to my local alarm server. And I also want to add another tab which will show me historical alarms. I'll keep historical predefined subscription. Okay. Go to runtime. You can see this is my historical overview of my alarms here, which I can filter, sort as I want. I can also create reports out of them. And I can go also for the other tab, which shows me the current alarms going on, which I can, with a double click, I can acknowledge them again. I can filter them, sort them, and so on, so on. I will, for instance, here select acknowledge from the menu and acknowledge all the objects. All right, good. I will go to configuration mode again, and I will insert my trend vaults viewer to show my trend data. I'll double click it. I'll use one tab, but also again I can tabs. I will add a new plot. I will select out of multiple types of plots. For instance, the second one. I will add a pen. Again, I will go for the liquid level. I will change the range from 1 to 10. And also I will change the time and rate of the plot to 1 minute for the period of the trend. And the last bit what I do, I will show my legend at the bottom of my plot. Okay. I'll go to runtime. I can see the tank level plotted here in the trend viewer. I may decide to go to configuration mode again and make those controls larger. So I can auto hide this property window, and make it bigger. Good. My screens doesn't have to be necessarily two-dimensional. I can also add a third dimension objects to it. I'll go for home. I will add a 3D view below my controls. Here, for instance. And I can either import my 3D objects of various formats, or I can use the symbol library here and insert an object from the library. Let's have a 3D tanks, tank 4, drag it and drop it to the 3D space. Using the Alt button and the mouse wheel, I can zoom in and zoom out. With the Alt still hold down, and also with the left button of my mouse hold down, I can rotate around the object. I can do that also in runtime. The core tool for designing of screens is Graphworks 64, but there is also a Workbench application in Genesis 64 suite, which can be also used for designing of screens, but also it can be used to maintain your configurations and the whole project on your server. If you open Workbench, first of all, you can see on the left side the Project Explorer with the applications included in your project, and on the right side you can see the configuration pane. If you want to see what's included in your project and you want to edit it, then the best way is to go over the project, edit project, and see all the applications included in the project. Any application that you want to remove from the project because you don't use it, you can just select it and click remove. Later on, if you decide to put that application back, you can just click add and add it here. You can see all the applications and access them here. Or you may have noticed that another way is to go over this list. This list can be more customized with add or remove buttons command, where you can specify that, for instance, in this list, you don't want to see the language aliasing or global aliasing, Gentray, framework server, security server, or BACnet. Whatever you show here, there's no effect on what is shown and included in the project. So all the applications that are included in the project will still be listed underneath the Applications tab here. Let us get back to Graphworks. If I open the Graphworks provider here, I can see all the Graphworks screen that I attached to my project. I may open my displays in runtime, or I can open them also in configuration mode, either in the same area or on a new tab. You can see I got now two tabs here, one with the runtime display, second one with the display and configuration mode, where I can explore its structure, change the properties, dynamics, and so on and so on. You can also notice that there is this ribbon, which is typically shown in Graphworks 64, the configuration mode, while this runtime mode here. But I can have also workspaces here, not only one large, but I can arrange my displays and other windows in different shapes. So I have, for instance, two displays here now. I will put this one in runtime as well. And into the third window, I can place, for instance, TrendWorks. And in the last one, I will show my alarms. But to view my trends or alarms or the screen, you can use Graphworks 64. But what makes Workbench unique is the possibility to configure my servers. I can configure my TrendWorks logger, for instance. I can configure my AlarmWorks server. And this is something that I cannot do anywhere else than in Workbench. and I configure those, it's better to have a bit more space. So I will close all those windows. Oh, good. And I will, let's say, open the configuration of my Alarmworks server. I can again open multiple configuration dialogues and switch between them as I need. Whenever my project is ready or I want to continue on configuration on a different site, I can pack the whole project and take it away. So I can go and proceed with the project that I will pack this project. I will write down the name, my project, for instance. I may decide to compress the file so as it's smaller, and I can also encrypt it or protect it with a password. I will select what should be the content of the package. So I've specified some Graphos displays. I want to have there also my TrendWorks logger, an Alarmworks server, and Alarmworks logger configuration. As for the displays, I will select only my postal examples. I'll click next, next, and I can show the log file when the operation finishes, or I can show it later on. Now I'm waiting until all the project is packed up, all the configuration from the SQL server and all the displays are compressed. And if I want, I have the log file which I can show. The whole package was created successfully, and I can take it away and unpack it on a different site. If you want to know more about Iconics and Genesis 64, you can have a look in help files, in application notes, white papers, and any other documents provided by Iconics, or you can also use the Gen demo. It's a suite of displays created in Genesis 64, and each of the displays try to introduce you into a different module or a topic related to Genesis 64 or Iconics. To use Gen demo, you can just click and use the navigation buttons, or you can also use jump list. You can open the carousel, which is basically a suite of files that are put together, and any of them can be opened from this carousel list. So for instance, if I want to know about Genesis 64 architecture, I'll just click it. If I want to know more about Workbench, I can have a look at the Workbench part. I can find out more about Alarmworks server design, TrendWorks, Hyperhistorion key features, and so on, so on. You are free to explore any of those displays. Also, if you want to find more specific files, you can go into this list and select a carousel list that you want. So if I want to know more just about Hyperhistorion, then I will click Hyperhistorion, and new list is loaded for me. Another useful feature in Gen demo is a learning center, which is to be found here. Again, that's another carousel list. If you want to find out more about, let's say, dynamics position, then you can use the interactive display here, which will introduce you into location dynamic, rotation dynamics, or size dynamic. If you want to find out more about 3D, let's go into, let's say, 3D dynamic position and learn about it. Last part of Gen demo consists of case studies and examples. So if I click case studies here, it will open me a list or a screen with different applications in the field, and I can select any of them and explore how Genesis is used. Similarly, there are examples of Genesis 64 that can be useful for you and you can also use them as an inspiration or for your convenience. If you decide to use Iconic software, you will need a license. You can select between a software license or a hardware key, depending on your project requirement. No matter which one you will pick, you will have to activate it. The activation is done over web. Iconics created a special designated Iconics web licensing page where you can log in and maintain your licenses. If you ever need any help with the license, you don't know how to activate it, how to transfer it, you can use the info center, which is here, divided into software part and hardware part.
Bueno, chicos, ¿cómo van las cosas? Claudia.
Sí, señor. No hay preguntas por ahora, profe.
Sin preguntas, ¿cierto?
Sí, señor.
Ok, entonces, listo. Vamos a recordar un poco algunas cosas de las que hicimos durante la semana que se supone están asociadas con la práctica. Entonces, acuérdense que hay un videíto por ahí que tenemos lo más de chévere. Yo aquí estoy, digamos que listando la presentación otra vez de la instalación. Volví a instalar acá el Ignition, entonces digamos que déjenme un segundo, yo pruebo algo acá y ya estoy. Por favor. Si esto me toca hacer un reinicio de computador que no quiero hacerlo, entonces pasaríamos a la máquina virtual. La host. Ok. Entonces vámonos con...
Profe, no lo escuchamos.
Sí, regálenme un segundito, por favor. Ya vuelvo con ustedes. Un momento, por favor.
Listo, sí, señor.
Déjenme un minutico acá y ya. O sea, quiero asegurarme que voy a usar el computador mío o voy a usar el de la máquina virtual. Estoy revisando esto en este momento. Déjenme un segundo. Listo, chicos. Entonces, sí, voy a usar el que tengo acá sin mucho misterio. ¿Listo? Bueno, entonces, vamos a recordar un poco el proceso de instalación, que digamos fue una de las cosas pues, muy sencillas, pero que vale la pena que revisemos acá. Entonces, pues yo ya lo hice. Igual este material se les va a entregar. Ustedes van a esa dirección, descargan la herramienta. Ahí uno pues simplemente introduce sus datos, los descarga. Una vez que usted ya lo ha descargado, ejecuta la instalación. Digamos que sigue todos los pasos por defecto. Típica. Lista para instalar. Se instala. Una vez que ha sido instalada, viene aquí la parte clave. Entonces, siempre hay tres opciones para descargar una, otra u otra. Sea la opción Maker, la opción Ignition completa o la opción Edge. La Maker, recuerden que es la que les digo que les recomiendo fuertemente que trabajen, o sea, por ella no hay que pagar y mientras que sea algo de hobby o algo de educación, ustedes la pueden usar. La completa dura 12 minutos, 2 horas, perdón. Y el Edge, pues no lo hemos visto, pero el Edge es como el producto insignia de ellos en este momento. Simplemente uno se da de alta con la licencia, la descarga y una vez que descarga hay que escribir acá localhost con el puerto que queda como tal. ¿Listo? Hay un quick start que fue el que hicimos en la clase. Se los recomiendo que lo hagan. ¿Sí? Ahí les va a pedir que hay que descargar el otro programa que se llama el Designer Launcher. Lo descargan. ¿Sí? Normal. Y digamos que vamos a realizar la práctica a partir de lo que está en este video. Entonces, este es el video del señor que está en Perú, que me encanta para este webinar y para ustedes en particular, pues básicamente porque aquí él cuenta cómo configurar el PLC de Siemens, que es el que ustedes tienen en el SENA, y luego pues comienza el proyecto como tal, ¿sí? Entonces vamos a tomarlo desde acá como guía. Entonces uno básicamente, ¿qué es lo que tiene que hacer con el Ignition? Vamos a cerrar todo esto que estoy seguro ya que me está funcionando en este computador, que lo acabo de desinstalar. Entonces vamos a seguir los pasos pues de este video. Dale un segundo. Voy a cerrar todo y voy a hacer un fresh start con ustedes. Entonces, lo que ustedes van a hacer ahora en la práctica, apenas comiencen, es que van a abrir un nuevo browser. ¿Listo? Y van a escribir localhost por defecto 8088 y comienza a contar. Es posible que aquí no esté verde, sino que esté en naranja, entonces deben decir reiniciar la aplicación, ¿de acuerdo? Entonces, aquí estamos. ¿Listo? Aquí estamos ahora. En este momento así lo van a ver ustedes. En browser. Localhost 2.8080. ¿Listo? Y se ve esto. Muy bien. Recuerden por acá que es posible algunas veces debo reiniciar la franja verde, digamos el temporizador. En eso presente. Listo. Entonces, una vez que yo ya, digamos que iniciado esta parte, esto es acá, aquí. Muy atrás. Es acá. práctica formalmente comienza en esta parte. Pero prefiero hacer esto así con ustedes que enviarles pues simplemente una guía porque no necesariamente va a ser tan chévere. Listo, entonces esta es la que tenemos que pegar acá. Bien, arrancamos acá, ya la había pegado. Yo que hice localhost 8080, está status, está configuración y eso es una página web que está corriendo en mi browser. ¿Sí? Listo, lo siguiente que yo voy a hacer después de estar en esta página es llamar el Designer Launcher. ¿Sí? Está el Designer Launcher. Y lo voy a maximizar y es la pantalla que ustedes se encuentran acá. Esta. ¿De acuerdo? Darle aquí el tacho para que sea exactamente igual y van a ver esto. Lo siguiente que ustedes van a hacer acá, dejando todo de una vez el camino con la miga de pan. Lo siguiente que van a hacer es un doble clic acá. Y lo vamos a poner ahí. ¿Listo? Entonces yo le hago doble clic acá y se me abre esto. Entonces aquí, digamos que el problema que tuve ahora es que me olvidó el password y hay una manera de reiniciarlo. Entonces estaba en eso. Entonces para mí es admin y mi clave. Listo, me funcionó. Y voy a crear. Bueno, ahí se me. Era esta. Aquí voy. Entonces doble clic. Y aquí me aparece esta. Estos son los proyectos de antes. Entonces, que yo tengo esto, voy a crear un nuevo proyecto. Voy a cambiar esta acá. Nuevo proyecto. Listo. Una vez que creo un nuevo proyecto, pues allá está la pestaña. Aquí así. Entonces, práctica. Ignition. Por la tarde. Y lo demás lo vamos a dejar por default. O sea, no le vamos a poner parent, no le vamos a poner user source, identity provider, default database. O sea, no le vamos a poner nada raro. ¿Listo? Me falta, perdón, aquí creo que lo debí haber dejado por default. Ninguna acá. Ok, esta está muy grande. Práctica. Sábado. Listo. Ese está bien. Ya me dio aquí la validez. ¿Listo? Entonces le digo crear nuevo proyecto. O sea, todo por defecto. La vez anterior, cuando hicimos el seguimiento, nosotros aquí usamos un template y habían muchas cosas hechas. En este quiero que arranquemos de cero, porque pues digamos que esa es la parte pues que podríamos también usar. La otra pues le ubica uno bastante, la que vimos en clase, pero aquí en práctica pues hagámoslo desde cero. Entonces le decimos crear un nuevo proyecto. A ver si vamos aquí. Aquí creamos un nuevo proyecto, sí. Ahí mostramos las dos definiciones. Y se me va a abrir ahora esta pantalla. Una vez que lleguemos aquí cuando esto termine de cargar. Digo que se me hizo... Ya abajo. Sí, entonces esto se llama... Y me sale esto. por defecto yo estoy aquí parado. En Vision. Aquí en esta parte. Es donde estoy yo parqueado en este momento. Entonces, es esto que está acá. ¿Sí? No le voy a borrar porque ya tengo los cuadritos como tal. Y lo siguiente que voy a hacer yo ahora es que voy a crear una ventana del lab. Y voy a hacer una principal. Y le voy a decir aquí crear. ¿Listo? Entonces yo la creo y me sale un lienzo. ¿Y un lienzo en dónde y cómo y por qué o para qué? Entonces yo voy acá. ¿Sí? Voy acá en este lienzo. Veo algo así. ¿Qué hago ahora? Quiero ver qué me está saliendo. ¿Sí? Quiero ver en este momento qué estoy viendo, qué voy a ver, qué opciones tengo. Entonces vengo aquí a Tools y aquí puedo lanzar el proyecto dentro de una ventana o ya un full screen. Cualquiera de las dos para efectos prácticos nos sirve. Entonces, cuando yo hago este lanzamiento, pues él comienza a hacer algo ahí. Y yo, si mal no recuerdo, tengo esto aquí. Esta no va acá. Esta sí aquí. Se movió. Se movió algo. ¿Se movió qué? Y apareció esto, miren. Wow. Username y password. Listo, entonces, username y password, ¿sí? Es el mismo que hemos introducido antes. Aquí se llama admin. Bien, comienza el starting project. Esta no va acá. Ahora sí va esta. Ahora, por ahora se ve así. ¿Sí? ¿Cómo es que se ve? Pues simplemente starting project. Y wow, miren, me salió esto. Una página web. Sí, aquí dice command, close, help. Sí, eso yo no lo puse, pero me sale una página ahí gris como tal. Listo, entonces ahí vamos. Tengo un lienzo, tengo un canvas, ¿sí? Para trabajar. Es un canvas. Vamos a ver si lo conoce aquí este corrector. No, no lo conoce. Dejemos el canvas ahí. Listo. Entonces vamos acá. Si aquí hay gente desarrolladora, Stexfield, ¿les suena? Numeric Testfield, ¿les suena? Spinner, ¿les suena? Formatted Textfield, ¿les suena? Bien. Entonces yo puse estas cajitas acá. No voy a entrar a hacer nada con ellas. Simplemente esto es porque nuestros amigos desarrolladores están con nosotros. ¿Listo? Entonces he colocado todas esas cositas como por allá y ahí voy. En la clase, los datos vienen de alguna parte. Entonces, cuando estamos acá en configuración, queremos hacerle otra vez el login. Él tiene aquí guardado el password. Aquí hay una cosa que dice OPC UA. Y aquí están los device connections. ¿Sí? Entonces, aquí no hay ningún dispositivo en este momento. Y no hay ningún dispositivo porque en el momento en que creamos el proyecto, pues dejamos todo en blanco. Hay la opción de que tenga el tab provider. Vamos a ver si lo hacemos por acá. Por ejemplo, aquí lo podríamos hacer con cualquiera de estos PLCs. Obviamente aquí no tenemos ningún PLC. Entonces, pues nada, no tenemos chance de esto. Ustedes allá tendrán el que tengan en el laboratorio, el S7500, el S7300, no tengo ni idea cuáles tengan. Si tuviésemos los de Rodwell, pues sería alguno de estos, ¿sí? O el Micrologics, por ejemplo. Si tenemos, por ejemplo, a Proton como proveedor de dispositivos, pues sería una opción. Entonces, por aquí tendríamos que tener, acuérdense, un Modbus TCP. Cualquiera de estas opciones nos servirían, ¿sí? Pero no la vamos a activar en este momento. Simplemente era para que se acordaran de dónde viene los datos. Entonces, aquí se supone que vamos a ver qué dispositivos hay. Por defecto está siempre este. Y aquí están las rampas. Y no están las rampas. Venga, vamos a devolvernos un momentico acá. Vamos a grabar este para no enredarnos un poco y vamos a hacerlo desde la creación, pero dejándole el default como tal. Démosle Save and Exit. ¿Sí? Y apaguemos este también y creemos uno nuevo otra vez rápidamente. Entonces acá activamos el Designer Launcher, todavía nos queda, le damos doble clic. Vamos a repetir, eso no nos hace daño repetirlo. Él arranca. Me va a pedir mis contraseñas. Creamos un nuevo proyecto y aquí pilas y ahora de una vez. Entonces, sábado, tarde, 2, práctica. Entonces, acá podemos usar este módulo PC. Podemos usar el tag provider acá, el default, ¿sí? Vamos a dejarlo igual sin nada. Aquí dejémosle si hay default database, perdón, default database no hay nada. Aquí está el users module, sí, práctica. Esperemos que todo salga así. Debe cargar otra vez. No le tomé el screenshot ahí. Acuérdense, ahora que estén jugando con él, de el OPC UA es el que nos debe quedar. Nueva ventana. Bueno, antes de crear aquí la nueva ventana, confirmemos. Tenemos devices. Aquí esté funcionando. Y no me está saliendo ninguno. No, ¿por qué? Si los acabo de activar. Bueno, no interesa. Entonces, vamos aquí a actualizar este, a ver si hay algo que no hemos encendido. Ya es. Dale un segundo acá. Prendamos este momento. Aquí está corriendo. Vamos a ver qué está produciendo. Listo. Esto hacía falta. Entonces, de nuevo, ¿cómo lo hicimos para que lo tengamos acá claro? Vamos a borrarlo. Listo, sí. Entonces, ¿qué hicimos? Vamos acá, a donde dice OPC UA Device Connections. Vamos a ir guardando esto. Antes de crear esto, dejémoslo por acá. Listo, entonces vengan. Encendamos el simulador. OPC UA Device Connections, acá. Adicionemos un simulador de datos. Vamos acá a Device Connections, ¿sí? Device Connections, y decimos crear un nuevo device. Lo creamos y buscamos el dispositivo programador, el Programmable Device Simulator. el simulador de dispositivo programable, es un simulador de PLC. Ubicamos el simulador de dispositivo programable. Stop. Lo siguiente. Entonces, simulador, datos. ¿De acuerdo? Y le decimos crear. Presionamos crear. Proporcionamos nombre. Y presionamos crear, ¿cierto? Luego, editamos programa. Programa genérico. Cargamos programa genérico. Ahora se ve así. Y tenemos las rampas de cantidades dobles. Tenemos los randoms aquí de valores booleanos. A ver si esto lo puedo volver entero 16 también. A ver qué pasa. Listo. Entonces la booleana 2, acuerde que nos quedó entero 16. Estas son read only. Pero aquí habían unas que se dejaban escribir, ¿se acuerdan? Listo. Y luego le damos grabar programa. Presionamos Save Program. Entonces, aquí vamos con, no, comentarios no, es un bloque de texto. Hay rampas, aleatorios, booleanos, etc. Voy a hacer esto más grande para que ustedes se acuerden. ¿Listo? Entonces tenemos estas cositas por acá, lo más de chéveres. Bien, entonces ya ahora sí, en teoría, al ejecutar aquí el programa y ver que está corriendo, deberíamos tener datos arriba. Deberíamos tener datos arriba. Vamos a ver si tenemos ya datos. Vamos a darle aquí esto. Entonces, vamos a ver Browse Devices. Ahora sí, mírenlo, aquí está, simulador de datos. Tal cual como lo pusimos nosotros allá. Entonces, aquí está la rampa. Bien, entonces vamos a llevarnos todos estos conjuntos de datos para la derecha. Entonces, vamos aquí a Tag Browser. Dios. Tag Browser, Browse Device. Vamos a pegarlo aquí en Paint para dejar el resalto donde tienen ustedes ahora que buscarlo. volvemos acá. ¿Listo? Llevamos todo el server. Muy bien. Ok. Ya, listo. Entonces, aquí vamos. Entonces, ventana del laboratorio. La creamos. Y volvemos acá con el text field. Para mis amigos desarrolladores que hacen estas cosas y más, pero digamos que para ellos esto es muy, muy natural. Simplemente yo los estoy arrastrando acá. O sea, no les voy a unir con nada, ¿no? O sea, simplemente los quiero aquí ponerlos para hacer énfasis en la parte que tiene que ver con lo que es HTML. El drop down, slider. ¿Listo? Entonces, aquí están todas estas cositas que las traje yo de acá y no les he hecho ningún binding. Acuérdense que el binding es el pegar, ¿no? Entonces, cuando yo vengo acá, busco el simulador de datos, busco la rampa, por ejemplo, la rampa 0, yo la traigo acá y la puedo enlazar, por ejemplo, con un tanque. Entonces, ahora voy a ver el tanque. Me traigo la rampa 1, la voy a enlazar ahora con un display. La rampa 2 la voy a arrastrar acá con una barra de progreso. La rampa 3, ahí. La traigo yo acá y la muestro con, bueno, los sliders. Traigámonos otro progress bar acá. De pronto algo nos... yes. Listo, dejémoslo así. Entonces, listo, tenemos acá varios objetos que vemos que se están moviendo porque el simulador ya los está moviendo. Ustedes ya, digamos que espero que me crean, no mentiras, yo sé que me creen, que todos estos datos vienen de, por ejemplo, estos doubles que están aquí saltando, pongámoselos con un numeric display, let display, ¿sí? Entonces, ya todas estas cosas las hemos creado, guardemos acá, save. Y aquí donde dice Tools, le decimos Launch. Bueno, antes de todo, aquí arrastramos los objetos. Hacemos cambios y arrastramos los objetos. ¿Perdón? Luego, aquí venimos a Tools, Launch Project y lo lanzamos otra vez. Lanzamos de nuevo. Y una vez que lanzamos de nuevo, Nos vuelve a pedir el usuario y password. No. ¿Qué ha pasado? ¿Por qué no me funciona? ¿Tengo alguno abierto? No, no tengo nada abierto. Debería funcionarme. Incluí mal los datos. Vamos a volverlo a hacer acá. Me está molestando con esto desde hace rato. No entiendo por qué. Esperen un segundo. Logout. Vamos a logout acá. Login. Admin. Password. Listo. Guardemos esta acá. Este se llama sábado tarde 2. Y debería yo poderlo ver acá sin ningún problema. Tiene que ver algo con mi antivirus que me está haciendo malas jugadas en estos días. Bueno, anyway, no se está dejando ver en este momento. Hay algo aquí que me lo estaba dando. Sin embargo, yo puedo aquí en el proyecto hacer un preview. Y aquí en preview, pues yo voy a ver lo que me está saliendo. Ustedes allá en el laboratorio, en el computador, vengan, les digo de una vez, aquí en la máquina virtual, ustedes van a poder definitivamente ejecutar la visualización. Espérenme un segundo, yo acá me paso. Aquí es la máquina virtual. Y aquí pues lo podrían ustedes ver sin problema. Ok, aquí Euler me da una clave respecto a esto. Vamos a dejarlo aquí de una vez en la guía. Esperen un segundo. Digamos que esa es la parte que nos puede fallar acá el laboratorio, y es con esto del usuario y del password. En un segundo. Ok, aquí ya terminó el periodo de ignition, no hay problema. Ah, bueno, este es el de la máquina virtual. Yo esta máquina la voy a cerrar. Listo, ya no tengo la máquina, estoy con mi computador solamente. Si lo lanzamos de nuevo, aquí me debería funcionar, pero no me está funcionando por el password. Sí, lo estoy escribiendo mal, ok. Bueno, y reiniciar el password tiene su proceso ahí, pero no lo voy a mostrar ahorita. Ese es admin. Gameplay, no sé por qué. Bueno, anyway. Entonces, hasta aquí va la práctica de ustedes. Vamos a revisarla rápidamente en qué consiste. Entonces, aquí Doyler me dice que les recuerde que el password acá me recuerda, me dice Euler, as es, perdón, username es usuario cena, Y el password es usuario Sena 01. Listo, tengamos eso ahí presente. Entonces, yo le voy a pasar esto ya a Doyler. Como tal, recuerden que la práctica no comienza con la instalación. ¿Sí? Recuerden ustedes que la práctica comienza acá. Doyler desde la 18. Me dan ganas como de generar 2 archivos acá de una vez para que no nos vayamos a equivocar. Entonces yo sí prefiero hacer estas experiencias así, con ustedes en caliente y no, pues no traerles la guía ya hecha para que la hagan, pues porque lo bueno del video es que uno tiene estas posibilidades, ¿no? Ahora sí. Estas se van para acá. Ok. Práctica para hacer debe. Si al final ya acaban, mucho cuando acaben acá y quieren seguir jugando un rato, pues recuerden esta otra. Recuerden este video. Entonces aquí nos vamos para esto es YouTube. Espero que no me salga nada comprometedor. Acá Ignition. Es este. Bien, dejamos esta acá. Y nos vamos acá. ¿Listo? Bien, entonces esta es práctica para hacer dashboards. Muy bien, y nos queda la otra. Y este es el laboratorio de sábado. Y esta es instalación. Entonces ya estos documentos los va a tener Doyler, ya se los voy a pasar. Y volvemos a repetir aquí la práctica para que ustedes tengan certeza de que les estoy yo pidiendo. Bueno, aquí Doyler ya tiene creo que los archivos que son. Voy a confirmar y volvemos a ejecutar la actividad. Doyle, entonces, si me está escuchando, por favor, le entregamos a nuestros compañeros las máquinas virtuales.
¿Cómo, profe? Qué pena, no lo escuché.
Doyle ya tiene las máquinas virtuales para que las compartan con los compañeros para que por favor puedan ingresar a las prácticas.
Listo,
¿Listo?
entonces las personas que tengan el acceso a los laboratorios y a las máquinas el día de hoy ya pueden dirigirse, por favor,
Listo, entonces,
al ingreso.
y volvemos a las 4, son las 4:10, 4:30, 4:25. ¿Listo? 4:30, 4:30. Volvemos a las 4:30 y vuelvo a repetir esta práctica y tendríamos después de repetir esto rápidamente para los que están acá, vamos a continuar viendo otros videos bien interesantes. ¿Listo, chicos? Claudia,
Listo,
¿estamos?
sí, señor.
Sí, sí estamos bien
Listo.
de tiempos, de descansos y todo, ¿cierto? Esto es lo comprometido. 20 minutos
Sí,
por
señor.
hora. Sí, aquí estamos un poquito pasados, pues, pero no me di cuenta, me emocioné yo acá, pero vamos hacia allá. ¿Listo? Entonces
Bueno,
pasan
sí,
los
señor.
otros y volvemos en 20 minutos a las 4:30. Chao.
Chao, profe, gracias.
Bueno, chicos, preguntas. Buenas tardes otra vez.
Hola, profe.
Hola,
No,
Claudia.
señor, no hay preguntas
No hay
hasta el
preguntas.
momento.
Listo, entonces voy a compartirles otro video ahora. La idea es que este otro tiene que ver con la plataforma IOT, pero esta es más de maker, más de como el electrónico que quiere hacer su propio dispositivo. Entonces, igual la idea es que en este espacio, recuerden, hay una mano alzada, buenísimo, alguien se escondió. En este espacio, recuerden, pues la idea es responder preguntas de este bootcamp, de este webinar que hemos tenido esta semana. Yo estoy aquí disponible y dispuesto para ustedes, pero mientras esperamos que haya preguntas, pues yo voy de alguna manera compartiendo algún material que me ha parecido interesante, que he recogido a lo largo de estos años. Y la idea, pues básicamente es que ustedes también lo miren y si ven que hay cosas que vale la pena, pues preguntar, profundizar con el mayor de los gustos. Entonces, continuamos en esta misma dinámica. Y vamos a estar acá hasta las 5:40 más o menos viendo esta clase de videos, pero recuerden que el objetivo de esta sesión es dar respuesta a las inquietudes que hayan resultado pues de la asistencia durante esta semana a este evento.
Hola a todos y bienvenidos a un nuevo video de este canal. El día de hoy vemos los videos del Internet de las Cosas explicando cómo funciona la plataforma de Arduino IoT. Por si no sabían, Arduino tiene una plataforma para conectar todas sus placas que tengan un módulo Wi-Fi a la Internet y estas puedan ser controladas y monitoreadas desde un dashboard. Si nosotros pasamos a la página Arduino, donde viene el IoT Cloud, podemos ver una breve descripción que nos dice que podemos implementación del Internet de las Cosas en pocos pasos con una placa de ellos. Y tiene algunas características como el entorno de creación, que es la plataforma que ellos tienen para hacer toda la vinculación al Internet, hacer todo el programa y luego hacer el dashboard. Los bocetos, que son los sketch o la que se le sube a las placas, la construcción de redes de sensores, que es lo mismo, el monitoreo de datos en tiempo real, que es útil si es que necesitas tener los datos en arrojo vivo, tiene compatibilidad con Wi-Fi. LoRa es una comunicación para largas distancias, tiene 15 widgets únicos y tiene una API que podemos utilizar para otros proyectos con otras tecnologías. Y está muy chido. Aquí te vienen algunos pasos, que es conectar el dispositivo, generar el sketch y luego monitorear y ver todos los datos que nos arroja los sensores del Arduino. Ok, aquí vienen algunos dispositivos que podemos utilizar en la plataforma, porque estos tienen la capacidad de mandar datos vía Wi-Fi o por internet. Este es el Wi-Fi 1010, que este es el que tenemos, que viene con el Arduino IoT OPLA, Kit IoT OPLA, el MKR 1000, el 1500, estos son más como que tipo industriales. Estos no los conozco, estos 4. El Nano 33 IoT, que es el que vamos a utilizar en un momento, y el Portenta H7, que es la línea de Arduino Pro. Acá también faltó, próximamente van a poner los dispositivos de otros fabricantes, ESP8266 y tal vez el ESP32. Hasta ahorita, si no tienes algún plan con ellos, no puedes no puedes implementar el IoT Cloud y todo su API en una de estas placas, pero próximamente sí se va a poder. Ya que dimos una breve descripción de lo que es la plataforma, vamos a hacer una pequeña práctica para ver cómo funciona y qué puede hacer. Para la práctica vamos a utilizar el A33 IoT. Puedes utilizar otra placa de las que se mencionó anteriormente. Y si tienes un plan Make, puedes utilizar el ESP8266. Un potenciómetro de 10K, un LED de cualquier color, me gustan los rojitos, y su resistencia de 330 ohms. Aquí tenemos el esquemático. Como en todos los videos, vamos a analizarlo rápidamente para no tener duda al momento de hacer el circuito. Como vemos, es otra placa, ya estamos utilizando el Arduino Uno y aquí cambian los pines y el orden, ¿vale? El Arduino 33 IoT tiene una lógica 3.3 volts, no es de 5 volts. Entonces, de un pin que tiene los 3.3 volts y lo vamos a conectar a la línea de alimentación de la proto. Además, el GND que tiene. La parte de los componentes, de este lado tenemos el potenciómetro y el LED. El ya lo hemos hecho un montón de veces. Los de las esquinas a GND y a 3.3 volts en este caso. Y la de salida lo vamos a conectar al pin A0, este que está aquí, el 1, 2, 3, 4, 0 del nano. Y del LED vamos a conectar la misma conexión, el cátodo a GND, el ánodo a una resistencia de 330 ohms y la otra pata de la resistencia, pin 3 digital del nano. Aquí no se puede ver claro cuáles son los pines, cuáles son los digitales, los analógicos, los de 3.3, los GND, pero si nosotros nos vamos al pin out, que los mismos de Arduino, aquí sí podemos ver, o así los pines, cuáles son, de qué se trata, los RX, TX, algunos se pueden comportar también como digitales, los analógicos. Ahora sí hay que ver toda la configuración. Ya sabemos qué hacer, vámonos a la instrumentación. Pero antes, si no te quieres perder de las prácticas, de los proyectos, de las tecnologías de software y hardware, clica el botón rojo que está aquí abajo porque traemos contenido nuevo. Perfecto, ya estamos aquí. Vamos a cambiar un poquito el fondo para que sea. Y aquí tenemos ya el Arduino Nano 33 IoT en la protoboard, nuestros componentes, la resistencia y el potenciómetro. Y también unos pequeños jumpers. Si podemos, dice algunos puentes acá para conectar el GND y los 3.3 volts. Lo bueno que tiene esta placa, tiene algunas muescas aquí como blancas que nos indica que estos son pines GND y está muy chido porque hacemos tanto. Los demás pues no los tienen del otro lado que pues no, a simple vista pues no se puede ver. Entonces vamos a colocar el potenciómetro aquí ya que tengo unos cablecitos conectados. Entonces lo vamos a conectar. Ahí está. Ahora con la ayuda del diagrama, ahí está. Vamos a colocar el pin de salida del potenciómetro, que es la del medio, a la placa. Entonces conectamos. Y si vemos, es el pin 1, 2, 3, 4. Entonces, contamos 1, 2, 3, 4. Ahí está. Esto del nano. Ahora solo falta el LED. Este es muy sencillo. Solo voy a utilizar este cablecito que está a GND para conectar el cátodo. El otro a otra pista que no tengo. Ahora, la resistencia, ahí sí va a ser el reto, al ánodo y la otra pata al pin que le corresponde. En este caso, vamos a checar cuál es el 3. Viendo el diagrama, el pin 3 digital, 1, 2, 3, 4, 5, 6. Es el 6 de aquí para acá. Entonces, a ver, 1, 2, 3, 4, 5, 6. Ahí está. Para que no sean tantos números o tantos pines, donde está el GND hacia la izquierda, solo son 2. Lo único que falta aquí es puentear los 3.3 al otro extremo para que aquí también tenga el voltaje. Tenemos aquí nuestro circuito hecho. Ya terminamos la instrumentación, vámonos a la plataforma y al código. Antes de plataforma, te voy a dejar aquí en las tarjetas el video donde se explica qué es el Internet de las Cosas, las plataformas y comunicación. Ya estamos en la plataforma de IoT Cloud. Si es la primera vez que entras, te va a pedir que te registres con esto. Ya tengo aquí mi cuenta y te va a salir esta ventana donde dice Things, que son los dispositivos que vamos a vincular a. Para iniciar un nuevo proyecto, vamos a darle aquí a Create Thing. Y darle un título. Vamos a ponerle test-1, como el de la otra vez. Y tenemos tres campos. El de variables, el de device, que es el dispositivo o la placa que estaremos utilizando. Y lo primero que haremos es seleccionar el dispositivo. Vamos a dar aquí a Select Device. Y aquí nos aparecen los dispositivos creados que tenemos. Si es la primera vez, te va a salir que no tienes ningún dispositivo y le vas a dar Setup New Device. En este caso vas a poner un Arduino device y si tienes un SP8266 le das a este, el Party Device. Le vas a dar a Setup, vas a conectar tu placa y automáticamente se va a configurar. Como yo mi Arduino configurado, me va a salir que no tengo nada conectado, así vamos a escogerlo. ¿Ok? Vamos a quitarlo de otro proyecto que tengo. Muy bien, y ya está. Te va a salir aquí el nombre que le pusiste a tu Arduino, el ID que tiene, el tipo, cuál es y en qué estado está actualmente. Ahora vámonos a agregar las variables. Le damos aquí Add Variable y en el nombre vamos a poner Pot Value porque queremos leer el valor del potenciómetro y vamos a poner otra para encender y apagar un LED. Pot Value. Y este va a ser de tipo entero. Sí, porque no tenemos decimales. Ok, entero. Y aquí son como dos configuraciones para la variable. Se va a comportar como read and write, que es leer o solo leer. Como no queremos hacer nada con esa variable, solo vamos a leerla. ¿Okay? Y aquí se va a actualizar el valor. Podemos poner onChange cada vez que cambie el anterior con uno nuevo o periódicamente, cada un segundo, 2, así. Podemos change porque a cada rato va a estar cambiando o podemos poner periódicamente. Yo le voy a poner así para que se ande refrescado un segundo. Bien, ponemos add variable, esperamos y listo, ya tenemos aquí nuestra variable. Vamos a añadir otra que se va a llamar handle LED, es el que va a manipular el encendido del LED. Y este será de tipo booleano, porque solo será 1 y 0. ¿Okay? En este caso, si queremos que lea y escriba, porque pues, va a cambiar el estado del LED. Y aquí será onChange también, porque no queremos que periódicamente esté lanzando ese. Entonces, onChange. Muy bien. Vale, la agregamos y listo. Por último, agregamos el network, ponemos el nombre de la red y la contraseña y guardamos. Ahí está, yo tengo aquí el mío y terminamos toda la configuración de la cosa, así. O para que se escuche mejor. Ahora vámonos a Sketch y como ven ya nos generó aquí un pequeño sketch con todas las configuraciones para que se pueda vincular la plataforma con la placa. Bien, aquí tenemos una función que se llama onHandleLedChange, que es el que va a dispararse cuando el valor de la variable handleLed cambie. Entonces, eso es interesante. Vamos a ver cómo funciona esta función. Bien, como queremos encender un LED y leer un potenciómetro, solo vamos a poner aquí en el void loop, pot value es igual read entre paréntesis a 0, porque el pin conectado al potenciómetro está en el A0. Y ya, esto es la parte del potenciómetro. Ahora, del handle para encender el LED, vamos a agarrar aquí la función y vamos a poner digital, right, entre paréntesis, la sintaxis que ya sabemos hacer. El pin donde está conectado LED, que es el 3, y luego cómo se va a comportar. Como aquí la variable handle LED, que es la responsable de hacer el cambio, se lo vamos a poner aquí. Handle. Lo único que nos falta es definir que ese pin 3 sea de salida. ¿Okay? En el voice setup, acá está el voice setup. Pin mode, entre paréntesis, el pin 3, y este será de salida. Y eso es todo. Terminamos la sketch. Si creen que aquí está muy chiquito, no hay tanto problema. Podemos abrir el editor más grande. Aquí a Open Full Editor. Nos abre otra ventana del navegador. Y aquí aparece plataforma para hacer los sketches más completo. Porque aquí vienen los ejemplos, las librerías, el monitor serial, unas referencias, la ayuda y toda esa parte que tiene un IDE de Arduino. Bien, y aquí podemos ir Go to IoT Cloud y nos regresa a donde estábamos. Ahorita vamos a utilizar pestañas porque uno va a ser para la configuración y la otra para el dashboard. Aquí en la barra de navegación Dashboards y le vamos a dar aquí al botón Build Dashboard. ¿Ok? Nos genera uno nuevo. Vamos a darle aquí en la opción de lapicitos para editar. Vamos a cambiarle el título. Vamos a ponerle el mismo. A ver si me deja. Test 1. No sé por qué se pone un title. Ahí está. Test 1. Vamos a darle aquí al botón Add para generar, para poner un widget. Ok. Vamos a agarrar que es como una gráfica semicircular que va de un rango. Cuando lo seleccionamos, nos aparece la configuración del widget. Aquí podemos cambiarle el nombre, ponerle pod para saber que este gauge es del pod, de todos los valores que sale de ahí. Vamos a linkear la variable que hicimos. Vamos a darle aquí, link variable. Seleccionamos el thing que hicimos, se llama test1. Y aquí nos aparece las variables que son compatibles con el único que es compatible es pod value. Entonces le damos clic y link variable. ¿Okay? Aquí nos parece que dice que podemos poner el nombre de la cosa o del thing. Si le damos que sí, nos va a aparecer aquí abajo. Si quieren ponerlo, si no, pues lo pueden dejar así como estaba. Lo voy a dejar así porque se ve cool. Ok, ahora el rango de valores. El Nano 33 IoT, sus pines analógicos son de 8, 10 y 12 bits. Hay que configurarlos para que sean de 10 y de 12. Por default son 8, así como en el Arduino 1. Entonces va de 0 a 1023. Muy bien. Entonces le damos Done y ya está hecho nuestro widget. Ya está configurado. Ahora vamos a Switch para cambiar el estado del botón. Bueno, del LED, no es del botón. Vamos a agarrar. Nos aparece las configuraciones. Vamos a cambiarle el nombre. Se va a llamar LED. Aquí se me olvidó del otro. Podemos ocultar el nombre, si ustedes quieren. Pero yo les recomiendo que tenga un nombre para poder diferenciar uno del otro. Si es que tienes más widgets del mismo tipo. Linkear la variable. Vamos a enlazarla. Escogemos test. Aquí el pod value no es compatible con el widget que agarramos. Entonces solo agarramos el handle LED. Ok, lo enlazamos. Ya está. Mostramos el nombre del thing. Y le damos done. Y ya. Eso termina nuestro dashboard. Como ven, aquí yo le di a estas flechitas para los widgets. Hasta podemos hacerlo más grande, más chico. Obviamente con la cuadrícula que aquí tiene. ¿Okay? Vamos a hacerlo del mismo tamaño. Ahí está. Solo le damos done y ya queda. Ahora vamos a subir el sketch que subimos a la placa. La conectamos y enlazamos la placa con el dashboard. la pestaña donde tenemos el sketch, ahí está. Aquí nos aparece que no hay un dispositivo encontrado. Entonces vamos a conectar, ahí está. Esperamos. Y ya, ahora sí, ya nos aparece que está con el Nano 33 IoT. ¿Ok? Está en el COM16. Verificamos y subimos. Aquí sí poquito porque estamos utilizando el navegador y una extensión. Bueno, no es extensión, es como un programa que se instala que se llama, si mal no recuerdo, Arduino Create Agent. ¿Ok? Eso nos ayuda a subir algún sketch que tenemos aquí en la plataforma al Arduino o a cualquier placa. Bien, ya está. ¿Todo bien? Podemos abrir el monitor serie. ¿Ok? Vamos a reiniciarlo para que vean que nos aparece. Ahí va. Esperamos. Y esto son las configuraciones que tiene la placa ahora mismo. Y aquí nos dicen, no, pues está conectado a mi red. Y ya está conectado a la plataforma de Arduino IoT Cloud. Eso significa que si nos vamos al dashboard, ya estará funcionando los widgets. Veamos. Voy a mover el potenciómetro. A ver. Vale, ya les puse la cámara para que vean. Si no, no será verídico. Vamos a mover el potenciómetro. Va bajando. Ahora lo subimos. Y ven como el coach o el... ¿Cómo sería en español? Como el medidor. Pues cambia su valor. Ahora con el LED. Veamos, voy a ponerlo más cerca a la cámara. Y si le damos on, prende el LED. Si lo apagamos, se apaga el LED. Podemos poner varios componentes, varios actuadores, varios sensores y poder manipularlos y leer los que nos manda por internet. Si queremos ver cómo funciona esta parte de las cosas, ahorita está conectado la placa a la computadora. Pero ¿qué pasa si le ponemos una fuente de alimentación distinta a la computadora? Vamos a utilizar una power bank. Okay, lo conectamos. Ahí está. Hasta va a prender. Y veamos si todavía funciona el dashboard. Ahorita no está funcionando porque lo desconectamos. Ahí está. Tarda un poquito de nuevo, pero como ven, sigue funcionando el potenciómetro. ¿Sí? Veamos si prende el LED. Prendemos. Y sí, efectivamente, está prendido el LED. Lo apagamos, lo prendemos. Y miren, no hay ningún cable por medio, ¿eh? Vamos a estar. Ahí está. Y así terminamos el video de hoy. Te haya gustado la práctica y que le hayas entendido porque es lo más importante. Existen más plataformas de IoT. Arduino IoT Cloud es muy intuitiva y tiene muy fácil la integración entre el dashboard y la placa. Comentarios si conocías esta plataforma de IoT o si conocías otras que has utilizado en proyectos tuyos. Pues lo que hicimos en nuestro canal de Discord, te lo voy a dejar aquí en la descripción. También puedes compartírmelo por DM en Instagram o etiquetándome en un video de TikTok. Aquí te dejo mis redes. Seguiremos haciendo videos utilizando esta plataforma, así que suscríbete si no lo has hecho y nos vemos en el próximo video. Hola a todos y bienvenidos a un nuevo video de este canal.
Bueno, muchachos, de nuevo, buenas tardes. ¿Alguna recomendación, alguna pregunta, algo que quieran comentar? Acuérdense que este es el espacio que tiene el webinar para que ustedes manifiesten sus inquietudes. Por aquí nos están llegando algunas preguntas. Muy bien. Ya un momentico las reviso mientras dejo listo una cosa por acá. Vamos a dejar listo acá el siguiente video.
Hay un
Sí,
estudiante que alzó la mano. Voy a
sí.
activarle el micrófono para ver qué aporte nos quiere dar.
Buenísimo.
Harrison, buenas tardes. Ya puede activar su micrófono.
Buenas tardes a todos. Pues de antemano, primero, muchas gracias a todos ustedes, pues a los instructores y a todos, pues porque la información ha sido bastante buena. Yo trabajo como instalador de cámaras y he estado en empresas donde he visto ese tema de las producciones. Por ejemplo, yo era que, o sea, yo que dije el tema de los helados, ¿sí? Yo trabajé en una empresa de Freño, que es acá colombiana, conozco al dueño y eso, bueno. El caso
Muy
es que
bien.
vi el tema de la producción, de cómo era el envasado del helado y todo ese tema. Y pues con respecto a este tema de que nos ha dicho el instructor, pues me gustaría aprender mucho más. Pero ahorita, por ejemplo, en el tema del laboratorio no pude ingresar y cuando ingresé me dejaron solo, entonces pues no tuve como la oportunidad de hacer el laboratorio.
Ok. Claudia, no sé qué contestar en esta parte.
Por favor. Sí, señora Harrison, ya se le indicó que podía nuevamente ingresar. Lo que pasa es que, pues, me comentaba la moderadora que la máquina lo saca, pero que hay que volver a ingresar. No pasa nada que lo saque, hay que volver a ingresar. Ahí estaba la sala, la moderadora me dijo qué sala y de hecho usted por ahí envió un pantallazo, decía sala 17, entonces pues puede ingresar nuevamente. Yo ya le había escrito que puede ingresar nuevamente y esto, y pues hacer su laboratorio o su práctica.
Y Harrison, yo a usted lo invito realmente a que descargue el Ignition, si tiene la opción de correrlo en algún computador y acuérdese la versión Maker. Digamos que esa versión Maker le ayuda mucho a desarrollar las competencias técnicas para que pueda, digamos, llevar a cabo esos proyectos que usted menciona muy interesantes que ha identificado. Fíjese que usted viene del sector de los CCTVs, de los sistemas cerrados de televisión, y ahí va usted a poder conectar al Ignition Maker, las cámaras, y ahí, digamos que mucha potencialidad en la herramienta y mucha potencialidad en su actitud para que las cosas le salgan muy bien. Entonces lo invito a que haga esa búsqueda, a que haga esa descarga y, pues obviamente ya las personas aquí están trabajando para que se pueda pues ingresar rápido al laboratorio, pero sí la invitación es que descargue la herramienta. Este señor parece como al del precio de la historia. Tiene un discurso también muy bueno, entonces se los voy a dejar para que lo vean. E igual, pues al finalizar el video, yo sigo por acá con el ánimo de contestarles preguntas. ¿Listo?
Listo, sí, señor.
Vlad here with SolusPLC.com. In the last 5 episodes on Siemens TIA Portal and S712Cs, we've programmed functions, we've programmed function blocks, we went online with our PLC, we've connected hardware both on the digital and side, and today I wanted to revisit the HMI. So in the past, we've added a few very simple buttons and very simple indicators to illustrate the power of HMIs and add a few process elements such as tanks, valves, and pipes, and then do some basic those elements based on a program that we wrote in an earlier episode and show you how to animate some of those objects in TIA. Any further delay, let's get started. Right, so a quick little demo before we do HMI development. Right here we have a tank as well as a valve that's going to infeed a product. And what you'll notice is press open, the valve is going to start pumping a liquid. The level of the tank is going to increase. Obviously, as soon as it's closed, the valve is closed and no liquid is going in. So I've already pre-written some of the logic and I've pre-created some of these components. We will be finalizing this application and learning how to build some of these HMI elements. Before we do that though, I want to some of the things that I've put in place in TIA Portal. So you'll notice a couple of things. First and foremost, we have a lot of the logic, the main. That being said, it is leveraging the function blocks that we've learned in the previous videos. And each one of those is going to come with its own tag database. So the tags are going to be encapsulated in the instance that they're going to be. And essentially what's happening here is that whenever the valve is being allowed to open through the push button, it's going to start the tank if it is allowed to do so. So you'll notice that there's going to be a tank filling permissive bit that is being the database of inside a tank. And that's very interesting. I really like this feature because it allows you to access not only block level, but it also allows you to point to some of those tags externally. And you don't need to specify an intermediary in order to do so. Now, the tank itself has, first of all, it has a way to be filled. It has a way to be, that's going to be based on the valve status as well as the pump status. But it also tells us, as I've mentioned, if it is allowed, then that's based on the level of the tank. We can look at the implementation of the tank very briefly, but if we look, happening is for simulation purposes, while the tank is being told to be filled, I'm just going to increment the level every 0.1 seconds or 100 milliseconds based on this timer. And of course, once it is filled, it's percent, it's no longer being allowed to be filled any further. And that's where this filling permissive bit is going to come. Similarly, on the discharge side, if somebody wants to discharge the tank, they can only do so until the tank reaches 0%. And in a real world scenario, this tank level would be read by a sensor instead of being simulated by two of these timers. It's not extremely important in our case. Now, if we scroll down to the HMI implementation, one thing that's worth mentioning, tag table. So what I've created in addition to the tags that are being used by the instances are specifically passed between the PLC and the HMI. Now, of course, we don't want to copy all of the tags in our system into our HMI because we want to actuate push buttons. We want to read certain levels. And so again, if I scroll back up, it's going to be under the blocks. It's going to be under IO tags. So if we double click here, we'll notice that from the outside, what we can do is we can open a close signal through a push button on the HMI or physical world. We can read the valve status. We can also send a start and stop to our pump, and we can read the tank level. And that's pretty much all the act on the HMI side. One convenient feature of TIA Portal is that you can copy all of these tags. So I do want to show this process. Right click, copy, or use the shortcut Control C. And if I scroll down to my HMI tags, and so what we can do is add a new table. I'm going to open this tag table, and what I can do is I can paste the tag. So right click, select paste, or use the shortcut Control V, and you'll notice that all of the tags will be pre-populated. What we can then do is synchronize with the PLC and allow this to automatically detect the connections that we're looking to make. So I'm just going to synchronize like that. And tags on the HMI side should now be usable in our program. Now, I've used the root screen of the HMI, which was already pre-created to me on the device, but I do want to go over some of the details on the elements that I've already implemented. Now, you'll notice that there's piping, which is gray, and some of the piping, which is green. So that's one of the ways to represent that there's going to be liquid. And some of the HMIs not going to like this practice. That being said, I still like to see these in different plants depending on the process. And so the way you can, or at least one of the ways that I found out personally is, number one, you can color the pipes like we've seen in the previous video. You can also use the visibility key. And so here, if we select this pipe that is green, you'll notice that if I move it over, overlaying that gray pipe. So what I'm doing here is I'm going to go into my animations visibility, and when number one is open, I'm allowing this pipe to be visible. In essence, overlaying the green layer on top of the gray valve is energized. The other thing that's good to pay attention to, so the buttons, we've already talked about this a little bit, but events, this is structured a little bit differently than the visibility portion, but on press, I am toggling the valve 1 open. So if I press this button, the tag valve 1 open is going to energize. And once I release, to de-energize the same exact bit in my program. And that's very important because that creates a momentary push button. My valve is looking for a momentary tag that's going to set versus just setting that tag and then unlatch the other push button. And the close button is exactly the same, except it's actuating the close push button bit. Level side, I use the element directly provided by Siemens. So here I can just drag this scale out and drop it like. And then what I've done is if I go into tag connections, all I need to do is add a new animation right here, press on OK. And this allows me to select a tag which we want to tie this into. And in my case, instead of selecting the screeners by default, I went into the tag table that we've created, and then it's only showing me the only tag that is available at rank level because it is a real value. I'm not going to select it here. I'm just going to delete that object, and I want to finalize the piping as well as the discharge valve for the system. So first and foremost, we're going to need the exact same buttons, except they're going to be run and stop. So I'm going to select the open button that we've already pre-created for the valve, Control V in order to put that in place. As I said, instead of being open and closed, they're going to be run and stop. Of course, you can customize your buttons. They should definitely look much nicer and more presentable on a real system. Here, we're going to get things working. So I'm going to scroll that up. So run and stop. And then I'm going to tie this pump. So I'm going to select the run button first, go into events. On press, I want to select a different to energize. So instead of energizing the valve, I'm going to energize the pump. So this is going to be the run. Push button, press on OK. Make sure to change both areas, both locations of the press and the release. So this also needs to be changed to our run push button, press on OK. Like so. We still need to color in the pipes. So I'm going to show you how I did it for and then take it off screen to finalize. So what I've done is I've copy pasted some of the elements like this elbow, and then I get into the graphics in order to find some of the elements that I've already used in my system. So if I scroll through this, locate the pipes, and here we've already have pre-populated colors of different pipe types. So all I need to do in order to mention, because what's going to happen if I just drag out a green pipe, you'll notice that it's quite bigger than what I've allocated. And so one of the ways to resize that is obviously to drag this down. If you hold shift, very important button, it's going to be proportions of the pipe as you drag up and down. That being said, I certainly don't want to recreate all of the pipes, delete that. And instead, what I can do is I can paste that green pipe over the gray pipe that I've just copied. So if I over, Siemens TIA portal is going to automatically detect that that's what I'm looking to do. And so I have a pipe the same dimensions as the first one that I've already spent time resizing. So all I then need to do is position the pipe as I would like. It looks like that. I'm also going to take this little segment, scroll down in my graphics, and I'm going to paste the pipe over that as well. We can reuse some of the elements once they are created. So the horizontal pipe, I can just copy it from up. I'll have to remember to change the tags, and it looks like it is of a different dimension. All right, so those are the animations of the pipe. The thing we need to do is to add a visibility element as well as a different image for the pump. So similarly to the pipes, I can go in a green image. It's going to look a little weird. Actually, I'm going to apply the same technique that I've talked about a little. I'm going to delete this green one, and I'm going to paste it over the same sized pump as before. And then I'm going to place it on top. Now, of course, this animation is going to look a little bit strange because there is no green liquid in. That being said, you can change the color of the piping and you can choose something different in order to make this run a little bit better, more pleasing to the eye. That being said, let's jump into the animation. So once again, if I move this over and then I put it back, I do need to add a animation on the appearance and visibility. So how do we add the visibility? Let's click on that. Actually, I do need to delete the appearance one. Let's go into visibility, and here we're going to into, let's see here, PLC tags, PLC tag table 2, and this is going to be on running. Press on enter, and you'll notice that there's going to be an error because for whatever reason it thinks that there's going to be a range tag, but we need to change this to be 1. So when the running status is high, meaning it's 1 or 1, it needs to be visible, and we can press on save. On that looks good. I'm going to piping off camera and show you the final result. And so here's our final screen. It can certainly be optimized and made to look prettier. That being said, we can close the infeed valve. We can also stop the pump at the discharge station, and the level of our tank seems to have stabilized. If we open the infeed valve, just as we've looked at in the past, the going to start increasing. If we close this valve, it's going to stop. If we run the pump, it's going to discharge the tank and lower. All of that logic has already been pre-written as I had shown earlier in the video. And if we open both locations, then the tank is going to stay at the same level, because the way I've programmed it is that it adds the exact same amount as it pulls out. Of course, if you want this, you could, for example, change the speed of the pump in a real world scenario. You would also measure the flow at the as well as the discharge. You could probably add some elements to the tank itself, and I would highly recommend moving these control push buttons to a different screen. In any case, that's all we have for you today. And if you have any questions, comments, or suggestions for future TI and Siemens videos, make sure to post them in the comments below or on our forums. Thank you for watching, and I'll see you next time. Such as tanks, types, and then do some basic animations on those elements based on a program that we wrote in an earlier episode, and show you how to animate objects in TIA Portal. Without any further delay, let's get started. So a quick little demo before we dive into HMI development. Right here we have a tank as well as a valve that's going to in product. And what you'll notice is as soon as I press open, the valve is going to start pumping a liquid the level of the tank. How's it going, everyone? Vlad here with SolusPLC.com. In the last What is going on, guys? Vlad here with SolusPLC.com, and as many of you know,
Bien, chicos, aquí volvemos a la sección de preguntas, o continuamos en la sección de preguntas. ¿Alguna pregunta? Bien.
No, señor.
No hay preguntas. Listo. Entonces, este video, ustedes vieron que cuando hablábamos de Ignition había tres opciones. La opción Maker, la que estamos usando aquí en el laboratorio, y a la derecha había una que se llamaba Ignition Edge. Edge es borde. Entonces, cuando tenemos el borde de lo que es lo remoto y lo local, ahí se requiere más procesamiento de alguna manera. O sea, yo puedo recoger datos y hacer un preprocesamiento, un filtrado, algo de inteligencia con esos datos, y no enviar datos por enviar datos, porque eso al final cuesta. Entonces, esa es como parte de la solución de Ignition, de proveer una parte como alternativa a esto del borde. Y digamos, Raspberry pues es un computador embebido muy popular en el mundo. Entonces aquí nos van a contar cómo es la instalación del Edge en el Raspberry Pi, ¿sí? Entonces vamos a revisar este video. Digamos que esto es bien chévere para los cacharreros que tienen el Raspberry y lo quieren poner a andar y quieren tener una RTU de borde, ¿no? Entonces, comencemos pues con él.
I'm a huge supporter of Rockwell Automation products. Behind me, you'll always see the HMI, which is the PanelView 1000 series. It is an HMI that I've used in many of my tutorials, and it's my Udemy course for HMI and SCADA development. That being said, a lot of you have been asking me for alternatives on how to, because of course this HMI model, the PanelView 1000 series, can be very expensive for many of us. Furthermore, the software package that runs on this is also a very limited trial. So it's a 7-day trial for Factory TalkView Studio. And therefore, it becomes very difficult to learn those platforms without investing a lot of money into the hardware as well as software. So the alternative is Inductive Automation. It is a company which has been gaining a lot of traction in the last couple of, they've started a number of years ago, but they have been growing exponentially. And they do have an offering which is called Ignition Edge, which is extremely capable. And I've been learning it myself, but ultimately we're going to be installing it today on what's called a Raspberry. And for those of you who are not familiar with the Raspberry Pi platform, it's essentially a $30 computer which has a RAM module and all the peripheral essentially outputs and inputs that you might find in a normal computer. So you have USB ports, you have a port, and you have an HDMI output in order to see something on a screen, but ultimately it allows you to run applications on a very inexpensive basis. And for an investment of around $50 total, I'll show you some of the other components that I recommend buying. You would install this in an industrial environment. You can get a platform that's going to run your Ignition Edge, which is then going to allow you to gather off the different PLCs that you see behind me, but also different other Siemens PLCs, Allen Bradley, Omron, any PLCs that cover Ethernet pretty much. You can get the data and you can create very nice panels in your on your computer. You can also store tags on a SQL database. You can create HMIs. You can create just different views on how to show data. You get alerts through email, through voice. So it's extremely capable, but we'll get into all of that in later videos. That being, we're going to install Ignition Edge. I'm going to show you step by step how to get it onto a Raspberry Pi, how to get communicating with it, and how to bypass all the errors that might come up during the installation process. So without any further delay, let's take hardware side. Before we get started with today's video, we just wanted to quickly point out all the great content we've been releasing on the YouTube channel. And this includes industrial automation, PLC programming, as well as HMI development. And if you enjoy this type of food, really appreciate it if you could click the subscribe button as well as the notification bell in order to receive the latest and greatest content we to the channel. All right, so here's the Raspberry Pi on my desk. For those of you who are familiar with the different Raspberry Pi models, there's 3. And as you can probably tell if you're familiar with these modules, I've already installed a couple of heat sinks. So the Pi runs quite a bit, I guess, higher once Ignition Edge is installed, and it's pulling a lot of data in and into a data. So it's highly recommended not to just purchase the Raspberry Pi, but also essentially an enclosure with some heat sinks. So I ordered off AliExpress. I'll put some links down below where you can buy it, and it came with the enclosure with the 3 heat sinks, 2 on the bottom, as well as a fan. So this is something, like I said, I would recommend purchasing if you're going to leave this on for of time. That being said, let's quickly talk about the Raspberry Pi models. So there are going to be some older versions, which I do right now. So this is the older version, which I believe had only 256 gigs of RAM. So that's not going to work very well, because I'll show you once again a setting in Ignition which requires a lot more RAM than that specific version, to be some incompatibilities. Therefore, I highly recommend that you purchase version 4, which is the latest, and that should be 30 years. And if you want to spend a little bit extra for the RAM and go all the way up to $55, that would be even better for Ignition Edge. That being said, the next thing you're going to need is, of course, an SD card, which is going to run our, so here I have a 16 gig SanDisk memory card. You can go up higher, but it's going to be very important that you flash the proper format, at which we're going to look in a moment. Next, you're also going to need a power supply. So the Raspberry Pi runs on a USB port, which is located right here. And that's going to be a 5-volt USB. Like I said, you can run it off your laptop, but ideally, if you place it inside of a panel or anything that's going to be a bit more permanent, you can have a 110 to USB converter like so. And of course, you'll need a cable as well. So that's just a micro USB cable, which plugs into the power supply and then the Raspberry Pi. And The other thing for the networks, we're going to be talking to PLCs which are on a physical network. We're going to need an Ethernet cable with RJ485 connected. And in my case, I'm also using an industrial DIN rail mounted switch. So this is an 8-port switch. You can definitely purchase a much cheaper version of a similar switch. It's just an unmanaged switch that you can use inside of your, or if you want to, or if you have on hand a static switch, then that would be even better, which is what you saw behind me sitting in the case. That being said, that's pretty much all the hardware you need. Let's start configuring our Raspberry Pi. Okay, so the first one to need is the software that's going to be the operating system of the Raspberry Pi. And what it's called essentially is the new software, or more commonly known as noobs. So this is the software that we're going to be loading onto our SD card. And you can download the official raspberrypi.org/download/noobs website or URL. And in my specific, prefer to always get the offline and network install, because usually there's interruptions with the Wi-Fi, and I've had it during installations. So what I do is I download the zip, and I'm going to save that in my specific folder, my local disk. And then just so I know where exactly I'm storing this, and I'm going to click there. While that's being saved, let's talk about the SD card. So I'm going to open my file manager, and here what you're going to be a lot of different removable disks, and there's going to be this boot folder and recovery. And essentially what happens at the Raspberry Pi, once it's loading the OS, it's going to break down the memory card or the SD cards into what's going to hold the OS and some of these separate things. Now, in order to restore that back to the initial, there's going to be this software. It's called the SD card formatter, and you can download it just by Googling that name, SD card Google. And there's going to be different versions in Mac OS or Windows. Here we're going to be selecting which memory card we want to format, and in this case you'll notice that there's going to be many of them, and some of them, like I said, they're just different partitions of the same memory card. So I'm going to select this recovery disk to select quick format. You'll notice that the capacity on the file explorer is going to be different than what we're seeing here. In reality, it is a 16 gig SD card, like I've mentioned before, so it's important to make sure that you're formatting the right hardware. So quick format, and then I'm going to call this our Pi SD, and we're going to double check that the type SDHC. See here, we're going to format, and do you want to continue? Yes. So it's very important that you use, because it's going to format in the right file type. So the file system needs to be FAT32, and the only thing that's going to run on the Raspberry Pi. If it's anything different, then it's not going to work. So let's close out of this, and now I only have this SD card listed as our Pi SD. And at this point, we can double check if the noobs has downloaded completely. So I'm going to show it in folder. And what you need to do at this point is just right where that you've downloaded the zip folder, and we're going to extract all. And we're going to browse to the SD card to select this PC, and then select the Raspberry Pi SD card that we just flashed. And I'm going to click select folder to extract. So at this point, once this is extracted, this is pretty much everything you need to get started with the Raspberry Pi. This doesn't have the ignition edge yet. This is just the layer which essentially holds the OS of the Raspberry Pi and allows us to connect remotely to it in order to configure the system further. All right, so unfortunately, there's no better way of capturing on the Raspberry Pi besides just filming the screen with a camera. So the quality may not be the best. That being said, I will show you all these key steps one by one. So what I'm going to do is I'm going to select the Raspbian full recommend. I'm also going to change my keyboard to English US, and I'm going to hit this install button. So this is going to tell you that installing the OS system, so it's definitely going to erase any data that you have on the SD card. So we're going to hit yes, and the Pi is going to essentially unpack all of the files, and it's going to install the OS, which, as I mentioned before, is called. And the next step that I always like to do is going to be to set a static IP address so that we can remote desktop into the Raspberry Pi, and we're going to be filming the screen through the software rather than using a camera. So it is going to become a little bit better. One warning that I want to give you is that you should not interrupt this process. This may cause your SD card to corrupt or errors on your installation, and you're going to have to sit through this again. And this usually takes anywhere from 10 to, so do give your Raspberry Pi a chance and just let it install everything it needs, and I'll see you guys shortly. All right, it seems that has been successfully installed. I'm going to press this OK button, and the Raspberry Pi is going to reboot. What you're seeing right now is a selection off the monitor, and the Raspberry Pi is booting back up. We see an image in just a second. Next steps are going to be quite straightforward. What we need to do is connect to the network, and we will have to change the stat address in order to be able to remote into the Raspberry Pi. And what that's going to essentially, you can have the desktop of the Raspberry Pi through your laptop or the computer that you're using to program. So here we are. So welcome to the Raspberry Pi. We're just going to cancel out of this. All right, so now that we are on the desktop, what I like to do first is to connect to the internet. And we do have this enable Wi-Fi. What we're going to do is first country, and I'm currently in Canada. So I'm going to scroll down until there is interesting. There we go, Canada. We're going to press OK. And at this point, I should be able to connect to my network on the wireless side. So I'm going to select the network, and I'm going to in the password. Okay, press OK. And so about the Raspberry Pi is that there's going to be a wireless card as well as a wired port. So what that allows us to do is essentially load files and be able to get Ignition Edge directly from the Raspberry Pi. And then at the same time, it's going to have an IP Ethernet port, which is going to go to my private network from which I'm going to connect remotely. So I'm going to issue a couple of commands in order to change the static IP address of my physical Ethernet card. So I'm going to type in sudo nano/etc/dhcpcd.conf. And let's see if this file has anything. So this file contains the definitions for our networks. I'm going to scroll and create essentially a new entry for my static IP configuration. This could be put in anywhere, but usually you do want to, let's see here, there's going to be two interfaces, like I said. So this is going to be the static IP address. So this is interface Ethernet 0, which is what we're looking for. And I'm going to just uncomment that out, and I'm going to get IP address. So in my case, based on my network settings, this is going to be a 1 here, and then this is going to be a 6. I'm going to bother with IPv6 or routers or the domain name servers. So we should be able to just work it like such. So what I'm going to do is I'm going to save. So Control X, and it's going to tell me to save them, to press Y and press enter. So we've changed the IP address. We need to reboot the Raspberry Pi, and from this we'll be able to remote desktop. So we're going to switch to the normal view that you normally see from my laptop. All right, so the Raspberry has been placed onto the private network, and before we start the remote desktop, I always like to ping the 192.168.1.6 is the IP we gave it. And as we can tell, the response, everything is communicating as expected. Next, I can launch the remote desktop app from Windows. I'm going to type in the IP, which was already said before. So I'm going to hit connect, hit yes. And at this point, we're going to be asked for a password. So the defaults are going to be Pi and then Raspberry. And I'm going to press OK. Essentially what's happening is we're remoting onto the desktop of our Raspberry Pi, which is sitting on the network, and essentially just to control the Raspberry Pi in a much easier way. There's no need to have an external monitor. There's no need to have 2 sets of keyboard mice, and we can do pretty much everything that we've been doing so far. So we can start the terminal, but what we need to do next is we need to a version of Ignition which is specific to the ARM processors, and that's called the Ignition Edge. And like I've mentioned of this video, you may choose to download Ignition and launch it and run it on your own laptop or desktop. That we recommend that you essentially install it on a separate machine. And if you have a separate computer or PC that you want to use for this, that's, if not, like I said, the Raspberry Pi is a great option. So I'm going to just search in Google Ignition Edge download and press enter. So Chromium is just a browser, which is a lower end version. And let's see here, Ignition Edge. So we should be able to go to the website of Ignition. You can just use this link on, or you can pretty much search for it on Google. So download Ignition Edge. And once again, on your laptop and then transfer it through the network to your Raspberry Pi, or you can do it the way I'm doing it right now, which is essentially downloading through the wireless network of the Raspberry Pi. It is going to be a little bit slow, like I said, because we're remoting in, we're all browsers, and the Raspberry Pi is not a fast computer per se, so it's lagging a little bit, as you can see on now. But we are going to download a different version. As you can see, they are trying to detect a version which is not going to Windows for us. And let's just scroll down. There's going to be other versions. Like I said, because we do need to select an ARM-based version. So we're going to scroll down through all of these, and what we're going to use is this Ignition Edge Linux ARM version, and this is going to be, like I said, for ARM process. We're going to click on this, fill out the information. So I'm just going to go through this quickly. And you can put in whatever, obviously put in sense. Okay, so that looks like it worked. So we are going to download Ignition Edge. It is going to take a little bit of time, as you can see down here. Probably can't see that well, but it's going to take 5 minutes to download it through the network. So we're going to speed through this to install Ignition Edge. All right, so it looks like we've got the archive downloaded. We can launch the command prompt, and from here we'll extract the files and then launch the server. So here we're going to change directory into our downloads folder. So let's see, change directory into downloads, and we're going to have to unzip. So sudo unzip dot ignition, and we're going to put that in /user/local/ignition, which is the recommended folder structure on the Ignition website, although you can extract it anywhere. Okay, so that did not like that. So let's do /user downloads. Can we do it like that? If we just do it, so let's do this, Ignition Edge. Fine, so we're just going to create a new folder inside downloads in order to store all of our files. And we'll give it a couple of minutes. It does take a little bit of time because the application was a little over a gig, a little less than a gig. So it's going to take a few moments on the Raspberry Pi before everything, and then we can launch the server. Okay, so it looks like the extraction is complete. We can double check that the folder is then change into that directory, Ignition Edge. And we do need a couple of files executable. So I'm going to copy paste a command which is on Ignition Edge's website. So I'm going to essentially allow a few files to be executable. And then we're going to launch the Ignition server. So once again, I'm just pasting a command. So Ignition start, and we're going to see if there's no issue. It's finished decompressing the runtime. It should give us an ID. And at that point, we should be able to go to the gateway. That being said, there's one thing that I always like to do with this installation, which is to run it on boot. And that essentially allows us to start the server without having to every single time go through these instructions, starting it manually. So what I'm going to run is I'm going to run another command once started. So it looks like everything is complete without any errors. I did have some errors last time I ran this test, so everything to be okay. So starting Ignition gateway, and everything looks good. So we did get an ID right there. I am going to run another command, so I'm just going to paste that in, and this is going to open the file which is going to start differ. And I'm going to scroll down within this file until the last exit 0. And what I'm going to do is I'm going to a few lines. I'm going to paste a comment, so start Ignition. And below this, I'm going to paste a line on the Ignition website which just pretty much starts the file. I will have to change the location. So instead of being user local, this is going to be, let's see here, home /pi/ down / ignition edge. And let's just double check that the that we're executing is in here. So ignition.sh, ignition.sh. So that's right there. It's good. Everything's okay. I'm just going to delete this empty line, and then I'm going to Control X. And of course, I'm going to save, press enter. Okay, so we can close out of this. What we're going to do is there's going to be two different options which we can go by. So from here, we can launch the browser once again, and we can enter local. We can type with a port number of 8088. So let's see, local host 8088. And if everything is okay, there we have it. So the Edge gateway is definitely, we are going to get started in a different video. That being said, before we conclude, I do want to show you that at this point, if the Raspberry Pi network, you can open a browser on your laptop or desktop, and here you can type in 192.168. Looks like I didn't have a typo in that port configuration. So here we are, we can configure the server from our main. Definitely very helpful. You don't need to always remote desktop at this point. You can configure everything on the server through main computer. Thank you guys for watching, and I'll see you next time. Thank you guys so much for watching my content. If you have any questions on this topic, make sure to leave the comment section below. And if you can spend 5 seconds of your time liking as well as sharing that video if you've enjoyed it, that would mean absolutely. And if you have any What's going on, guys? Vlad here, and welcome back to the on Ignition. And today we finalized the installation. There was nothing to click besides just installing Ignition onto the Raspberry Pi after we finalized. And at this point, we can log into the Ignition Edge. And as you can see, I'm in view, which is essentially this home tab right here. And we're going to be looking at how to pass some tags from our PLC, the Compact Logix L24ER that we've seen many, many times, into the Ignition Edge application in order to use that tag for different data. Without any further delay, let's get started. Before we get started with today's video, we just wanted to quick all the great content we've been releasing on the Solus PLC YouTube channel. And this includes industrial automation, PLC programming, as HMI development. And if you enjoy this type of content, we would really appreciate it if you could click the subscribe button as well as the notification in order to receive the latest and greatest content we will be posting to the channel. Okay, so the first thing that you're going to notice is that the trial is probably going to be set to 2 hours, but every 2 hours the trial does expire, and you do need to in order to reset the trial. Now the sign in is going to be dependent on the login username and password that you've chosen during your instance. For me, it's going to be these credentials. I'm going to click on sign in, and at any point in time, you can just reset the trial. This a little reset button on the bar, which is going to be orange. And once again, the trial mode is going to reset to 2, giving you plenty of time to test the different features of Ignition Edge or the full version of Ignition. That being said, what we're today, like I said, is how to link our tags back from the PLC. And just to give you a quick little reminder, so the PLC, once again, that's the 1769-L24ER QB1B. It is the PLC that we've been programming for quite a while now. And I do have a separate program which is set up in my main task under Ignition Edge. And I do have a couple of little routines that I'm still working on, but it's going to be some faults. There's going to be some system statuses. But ultimately, what we do need to look at are the tags which are created routines. So there's going to be a set of booleans. So 256 booleans. There's going to be 50 dints, 50 reals, 20 strings. And last but not least, some internal tags to these routines that are not going to be passed. That's going to be 56 booleans. Now, what I'm going to do here, first of all, I'm going to add a new set of tags just so we can go through the process from the beginning. So I'm going to create this rpi, and I'm going to call this edge under, let's say, boolean number 2. And it's going to be local, it's going to be bool, I have 256 of them. I'm going to press enter, and the tag has been set in place. Now let's go back to our browser, and I'm going to go down to OPC clients and OPC UA. And here we'll click on device connections. So device connections is what's going to allow us to set up communications to different PLCs. Notice is that I already have the Allen Bradley PLC set up, but I'm going to just copy the name. I'm going to this PLC connection just so we can demonstrate that from the beginning. I'm going to delete the device and click on create new device. Here you'll see that there's going to be all kinds of different drivers depending on the flavor of the PLC that you're going to be connecting to. There's going to be a lot of different drivers and some Siemens, and I believe you can install a few different ones as well. The driver that we're looking for, and you do need to pay attention to the firmware revision. So here it's a default one is connect to a Compact Logic's firmware 20 and prior. Now remember that if we switch back to our Compact Logics, it's going to be listed all the way at the top here, which is 30.11. So it's definitely not prior to version 20. It's definitely Control Logics with V20 and prior. And next we have connect to Allen Bradley Logix family devices, including with firmware 21 plus, which is exactly what we're looking for. So we're going to select this driver. Like I said, pay close attention to PLC you're using, and I'm going to scroll down and press next. At this point, I'm going to give the PLC already in there. The description is optional, enabled. That's what we need. And next, we're going to give of course, our Raspberry Pi, which hosts the Ignition Edge. It needs to know exactly where the processor is located. If I switch back to the processor, you'll notice that the IP address is listed right here. It's also listed on the spreadsheet that I've shown you a couple of videos. And so we can put that into place. There's going to be a few more options. I'm extremely familiar with them, but we can just read the description. So the maximum amount of time to wait for responses from the processor, we can definitely leave it at the default for now. 2 requests, slot number 0. So this is important if you're using not a Compact Logix, but essentially a Control Logix PLC, then it's going to be different depending on which PLC you're connected to. Optionally, there's going to be a path. We are connecting directly once again, and that seems to be fine. So we're going to create a new device, and we have a PLC. We can see that its status is set to connected because the router Ignition Edge is going to try and ping that PLC and make sure that it's what we've specified. Next thing that we do need to check, which is really handy, is this OPC Quick Client. So if we go into OPC Quick Client, we can add the OPC UA server, and here if I expand these folders under, you'll notice that we'll have our PLC listed here. And by browsing through here, we can find the exact tag that we're, and just not to get you too confused, once again, a quick reminder, under the main task, we have this RPi Edge, and we should find these tags under the local tag structure. So let's see if we can find them. And program, let's see here, Ignition Edge, RPi Edge Ignition. The tag that we created at the beginning here was RPi Edge underscore bool2. And if we expand this, you'll notice the structure is a little bit different. And the reason for that is because the Booleans are transferred different manner than what you would expect. They are essentially treated as bundles of dints. And that's because we're using an OPC server, and essentially it doesn't pass the full array, but it breaks it down as demonstrated. But in total, you should have the same amount of Booleans. They're just, like I said, referenced a little bit differently. Now, our next step is going to be visualizing some of this data. So if we go back to home, you'll notice that there's going to be a panel with Ignition Designer Launcher. Now, you can either download this application. I've already done so I can launch it from the desktop, and I'm just going to open it right here. Now, automatically, if you add a designer, you should be able to find the location on the Raspberry Pi. So for me, it's right here. I can see that it's running. It's also running on my laptop, and it's running on a separate Windows server I have in my office. But essentially, we can cancel out of this. You can add your own gateway. Click on this launch button, and what this is going to open is the design interface for your specific panels. So from here, I'm not going to go into too many details in this situation, but I would do is I do want to add the tag that we've created. So inside of this tag browser, you'll notice that we do have RPi ignition. That being said, the tag that we've added recently, or the tag that we've added in this video, is not in this. Now, what you do need to find is we do need to find the OPC server. So we're going to click this Browse OPC servers button, and inside of this little pane, which you can actually keep inside of this view, do much more than this. So let's make it a little bit smaller like that. Inside of this panel, just like we did through the web interface, I can go into my devices, I can go into Solus PLC Compact Logic, and here I can find once again the same program, and I can find a tag that we've created. I can take this entire folder. I can select individual tags, but what I would like to do is take that entire array. I can drag this into the program over here. And at this point, what's going to happen is Ignition Edge to start looking at these tags. And if I expand this, I'm just going to kind of move this over so that we can see a little better that the values, like I said, they are treated as integers, but we can expand, we can start looking at the different booleans that we're getting from the PLC side. So let's just really quickly, I'm going to make this a little bit smaller just so we can test the communication and make sure that everything is working as we would expect. So if I change my first boolean, which is right there for a second, and I'm just going to change a lot of different booleans at random. And as you can see, the values, so the Raspberry Pi, which is running Ignition Edge, is receiving the tags the way it should be. And the tags that I've created previously, they are going to be used as well. So if I open the real array, and then I go back into my PLC, and so that's going to be mapped to this real array. And I type in some arbitrary number just to test it out. Let's see here. You can see it appear on the Raspberry Pi side in Ignition Edge. So that's really cool. Everything is working. We're talking, like I said, we're passing tags from our PLC, currently development environment, but we are going to be looking on how to set up projects, how to build different applications through this. At very core, you do need to understand how to pass tags from your different devices. And just to go back to the web, you can certainly configure multiple devices, and you can be gathering tags and data from different sources at your plant. Thank you guys so much for watching my content. If you have any questions on this topic, make sure to leave them in the comment section below. And if you can spend time liking.
Bueno, chicos, digamos que ¿por qué les dejé este video? Miren que en la parte teórica y en la parte práctica de este webinar, estuvimos hablando de Ignition. Un compañero nos envía un mensaje y nos dice, vea, interesante, a mí me gustaría aprender más del tema. Estos son los caminos para aprender más del tema. Definitivamente. Uy, yo vi una pregunta ahí que se me escapó. Definitivamente, ¿me podría decir qué es firmware? ¿Es algo malo para la planta que mostraron? Por favor, gracias. Ok, Julián, firmware es el programa que trae un microprocesador por dentro. ¿Sí? Suena como malware, pero firmware es, digamos, formalmente el software que tiene adentro un microprocesador. No es Windows, no es Linux, es una cosa mucho menos elaborada. ¿Sí? Entonces, ahí le dejo ya, digamos, la respuesta a eso. ¿Por qué les dejé este? Entonces, si ustedes quieren, digamos, salir del equipo comercial y usar ya sus propias cosas y llegar a un HMI robusto, Linux es mandatorio, ¿sí? Entonces, digamos que ahí vimos primero cómo toman la Raspberry, cómo la formatean, cómo le instalan el Edge, y luego cómo lo configuran y luego cómo lo usan con un PLC. Era básicamente reafirmarles que lo que hicieron ustedes en el laboratorio, lo que vimos acá, pues es totalmente real e industrial lo que hay ahí. De nuevo les digo, este es un espacio para hacer preguntas. También me aburrí mucho quedarme aquí esperando por las preguntas sin hacer nada con ustedes, entonces por eso les reproduzco los videos, pero recuerden, el espacio de la tarde de hoy, sábado, y de todo el día, pues es un espacio para preguntas. Y también, pues, digamos que las personas que no han hecho las prácticas las puedan hacer. Entonces, digamos que yo ya doy por terminado la sesión de hoy, nos volvemos a ver el lunes. En la mañana vamos a también revisar algunos videos sobre IoT. Vamos a generar una práctica, vamos a ver cómo le damos manejo al asunto de las cuentas de Azure. Y en la tarde, pues lo mismo, vamos a ver unos videos y continuar con el espacio para hacer la práctica con Power BI. Y digamos que eso es todo por hoy. No sé si tienen alguna última pregunta o pregunta última.